Are we live? Are we live?
Yeah, give us the, can you hear me?
Are we live? Can you hear me? Can you see me? Are we live? Okay. Well, David, you could always plug into that to hear live audio. Let me know if people can hear me and can see me. Can people hear me? Can they see me? Well, there's about a 20-second delay.
These headphones are not working, so I'm disconnecting them.
Okay.
Yes, they can hear you.
Well, that's great that you can hear me because I have important things to say. And one of them is I'm at Formnext. We're at Formnext 2023 here in Frankfurt, Germany. And it's been just a whirlwind up to this point. I don't think I'm too sleep deprived. I think I've gotten enough sleep. I think it's the proper way to say it. I'm properly caffeinated. I've had a sandwich. Producer David is right there. Peter on camera over there. And I'm excited to bring up our first of many guests. And this is my friend Sasha from Mesago. Come on up, man.
Hello.
Hey.
Good to see you. Hi.
Welcome to the stage here.
Thank you very much. Hello. Hey.
So everybody out there, they want to know what you do. So Sasha, tell me what you do from Mesago.
Hey, I'm organizing this show.
You organize Formnext.
Yeah, so it's really combining, a love for a technology with organizing an event like this, bringing all together guys like you, reaching out to guys like you. Hey, that's perfect.
I think it's perfect. Well, Now Formnext is one of the world's largest additive shows, if not the largest, correct?
Yeah.
How many people, how many companies, how many booths are here this year?
Yeah, so it's highly exciting for us. We have right at the moment 859 exhibiting companies here in 4 exhibition halls. So it's the whole world of additive manufacturing here inside. That's crazy. Also, when you take a look around what's happening at the moment all over the world, this is great, absolutely great. So we are back in the figures of 2019.
Really?
Before Corona happened.
Oh, that's right. Because we had that lull in everything while there was the pandemic going on.
Exactly.
859 companies represented here. So to give people an idea of how it's laid out, there are these massive halls that are numbered, and Formnext takes place in Hall 11 and 12, both on the first floor and the second floor. So 859 companies are taking up the space over 4 different massive halls.
That's crazy big. And just to give you a size in square meters, it's 54,000 square meters. So now we need to maybe recalculate it in square foot.
No, see, in 3D printing, we measure things in millimeters and centimeters. So square meters is perfect. That's what I'm going to say.
Yeah.
So 859, let's see, across all of these booths then, if you're the one organizing it, how deep are your fingers into the pie? Are you talking to each of these companies to tell them about the benefits of a Formnext show, or are you kind of overseeing everything? And I have a follow-up before, when you answer this, I kind of have a follow-up in mind.
Yeah, but as you know, it's not one person. It's a whole dedicated team connecting with the companies. And we are working in Mesago, also in the Messe Frankfurt group, which is our mother company. And Messe Frankfurt also has colleagues all over the world. So we have quite a very international network because of these 859 companies. 60% are international ones. So,
really?
So it's really the result of a very strong and big network and a highly dedicated team. That's the case.
You must have, to be able to bring in 60% of a show that has 859 participating companies, to have them come from outside of Frankfurt, Germany, from an international audience, really speaks to the benefit that Formnext offers. But the reason I talked about that, and I had a follow-up question, is because I wanted to know, do you have any personal experience that was just wonderful? Have you had a conversation with a participating company, or possibly a vendor, possibly a participant, someone who said, this Formnext changed my life?
Yeah, let's go into one vertical we talk about, which is the medical sector.
Which is big and represented here.
That's a very big sector. There are some, a lot of driving sectors for the technology. The aerospace guys were very early. Now today, also to the geopolitical situation, security and defense is
Yeah.
a big sector and has always been a big sector. The automotive industry has been one. But
That's right.
the medical guys were also very early adopters, and still for today, and we just need to look maybe 10 meters in this direction where we can see some of the samples. It's, hey, this is the technology touching the body and being inside the human body.
Right.
Making life for a patient easier. And for me, this is still, let's say, also the most empathic part of the technology, where this technology really helps people everywhere.
Oh, absolutely. We've actually talked about those sort of technologies from the additive side. We featured the company 3D Serum, Cinto, on the show and had a printed skull that had a ceramic implant and talked about how ceramics are really fantastic for implantation in the body because they're not just biocompatible or they're not just biotolerated, they're biocompatible, and the meat of us can grow into it, which I think is just fascinating. And those sorts of technologies, though, are what people can see at a Formnext show.
Yeah, definitely. So it's on one part, it's a highly industrial show. So that's when we started it, 2015. It's a very young show, but we always focused also on the industrial process of additive manufacturing. But the difference is not so far away also to the consumer world, where the basic principle of a printing machine and about the process is the same for a small size on a table and a big size in an industrial environment.
Absolutely.
That's great. And you need to be, that's what we also talked a little bit in forefront, you need to be nerdy also in the industry. And therefore it's a good connection to bring this together and to share minds and to push forward the technology.
Well, I love that you brought up how you started with more of the industrial process and the industrial machines, because today at Formnext 2023, we've seen a lot more consumer brands find their way into a more professional workflow. In fact, I know Elegoo talked about a new 3D printer, 800 by 800 by 1 meter, that they launched here at Formnext. Prusa 3D 2 years ago launched a brand new professional tool changer at Formnext. And so in your mind, how do you see Formnext going forward? Where do you see the industrial side and the consumer side coexist? Do you think more consumer companies will come to Formnext to showcase more professional technologies? Or do you think you'll see a lot of industrial companies sort of come down to a more simpler process, a less expensive process to be able to showcase at the show? Not saying go consumer, but lend themselves towards the consumer side with a less expensive process or less expensive materials. What's your view on that?
Yeah, you perfectly described it. It's also a question.
Well, thank you.
Yeah, it's also a question about cost per part and about where is the added value out of additive manufacturing.
Oh, yes.
You know this much more perfect than me. Looking back some years, there was a world in a hype of additive manufacturing, 3D printing, where everybody of us was told, maybe in 2 or 3 years, everybody of us will have a printer at home. We will receive some data and we will print a lot of products for ourselves.
Yeah, the 3D printing was the all-encompassing solution, is what we were told at the very beginning.
Did not happen.
I know it did. Well, and I'm glad it didn't, really, because
it didn't happen on the consumer side.
No, it didn't.
And it didn't happen in the industrial side.
Okay, so on the consumer side, which I can speak to, the promise of long ago was the 3D printer was going to be in everybody's home, much like a microwave oven, and that didn't happen. And I think rightly so, because 3D printing on the consumer side is a tool for production. It's not a Star Trek replicator. It could be one day, but for now, what we have are these great digital fabrication tools to be part of a toolbox that people can use to make their production better, to make manufacturing better. So then, does that lend itself to the industrial side as well?
I think exactly, because it's not anymore about talking of a replacement of conventional manufacturing technologies. This will not happen. It's about finding the right place in the right manufacturing environment for an AM process to be implemented to create added value.
Okay.
And that's really still a process to go on, because then it's the challenging questions about line integration, about automation, about standardization. Not very sexy when you look at the words.
Well, I guess it depends who's looking at the words.
Yeah, but it's necessary to bring this process, to bring additive manufacturing in the industrial world, and this happened already the last years, and it will happen in the years to come, because it's not finished at the moment.
No, of course not.
And that's the development also we can see here on the show floor.
You know what? You brought up a really good point of how it's not finished and it's gonna continue, and that lends itself to some of the stuff that I think about, because I get approached by people here at the show that say they work at some of these companies because of what they've seen on the show, where we've been able to cover the industrial process or these big professional machines. And while they aren't targeted towards a consumer audience, the people that got inspired found the companies that make the machines or make the materials or utilize the machines and materials, and actually got jobs here. And so I know we don't have a lot of time. I have a couple more questions, but one of the things that I really wanted to ask you about are those people. How do you see additive at the professional and industrial level in the next, say, 10 years, with what's going on in the inspiration of young people at like maker spaces and educational facilities? How good of a job are we doing with the young people today to make sure additive survives and flourishes tomorrow?
You do an exactly great job in doing this, because
Thanks, Sasha.
but you know, one part is the industrial side with the big manufacturing companies, the industrial environment, the engineers working there. But additive, in my opinion, is a technology really inspiring and inflaming the young generation, maybe not only to work in the internet, for example, or not only to work in the design or something, but really to go the harder way, to go into engineering, because at the end they can contribute together with engineering, I think, to our future of manufacturing, and at the end of our future as human beings. Because with additive at the right place, I'm sure we can really create a little tiny bit of a better future for us.
I think so.
And that needs the young generation out there.
Absolutely. Okay, well then I'll keep doing what I'm doing so long as you keep doing what you're doing.
We keep doing.
One final question, Sasha. I know we don't have a lot of time, like I said, but you, as a person who puts on the largest in the world additive manufacturing show, you oversee it, you have a giant team, 60% come international. Like this show is massive. It's big, it's industrial, it's heavy duty. Do you 3D print at home? Do you have yourself an inexpensive consumer machine that you make trinkets for friends? I have to know.
I know that you will ask, and I need to give the answer no, because, but I tell you why. Because if I would choose one of the machines, there would be many, many other guys asking me, hey, why are you using this machine and not mine? And at the end, I would have, I don't know, maybe 20 machines running at home, and then it would be too much.
20 machines at home is too much. Then you have to get your own studio and start a YouTube channel.
That's it.
Well, I know that we've got a lot of other people coming. Sasha, I just thank you so much for coming on board. I'm really thankful to have you here. And I can't wait to see the rest of Formnext, and hopefully have us back next year.
Enjoy the show.
Thanks, man.
Thanks. Bye-bye.
See you later. Well, that was amazing. That was Sasha from Mesago. Obviously, Mesago putting on the Formnext show where we're at. Wow, what a way to start off. Do we have any questions? Is anybody coming out? Look at that. Oh, hey, Zombie Hedgehog. Look at that. Thanks for the event coverage. Really glad to bring it to you. Oh, man. Brian, Maker My Nexus is there saying, hey to everybody. Brian Vines is there. Look at that. How's everybody doing? Lots of high fives, little pink high fives. Oh, this is good. Obviously, being able to put on a show like this is incredible. And I'm really thankful for Sasha to be able to come on here and give you guys a glimpse at what's kind of happening behind the scenes 859 companies, 60% of them are international to Germany, coming from all over the world, populating 2 different buildings, each building with 2 different massive halls. So if you ever have the chance to come to Formnext, I highly suggest you do. And if you think to yourself, industrial additive isn't for me, that's not right, because it's for everybody. Even though you can't buy an industrial machine, you should learn more about it. And any experience you have in additive on an Ender 3 directly translates to experience that you can use here in the field.
You ready for our next guest?
I think so. Hey, let me give you this, Peter. There you go. My next guest needs no introduction.
Hi, which camera am I looking at?
You're going to go to that one.
Here?
This is
Okay.
Andrew Sink from Carbon.
Hey, Joel, how's it going?
Dude,
Good to see you.
it's good to see you. Carbon, obviously, one of the favorites here at Formnext, always with a cool booth showing off really neat uses of materials. And I think that's what I really appreciate about Carbon. You see a lot of companies here that have a machine to showcase, but rather than the machine, you're like, here's what we can do with the machine.
Absolutely.
So what can we do with the machine? I hear you have parts.
We have, so I'm going to show you some. This is our new material, and it's very colorful.
Oh, wow.
Red.
Okay, you're touching
orange,
it, so I can
yellow,
touch it, right?
green. Yeah, I'm trying to get Roy G. Biv. I'm starting to memorize it. It's going to take a minute. So
Red,
what you're
orange,
looking
yellow,
at-
green, blue, violet or purple?
Viv,
Viv,
violet.
Violet,
Yeah, I
okay,
think we're
okay,
good.
violet.
Yeah,
What-
so
What makes these special?
so let's kind of talk through it for a minute. So at Carbon, we spend a lot of time on consumer products. So we're a 3D printing company as opposed to a 3D printer company. So we do a lot of 3D printing of consumer products, and with that comes an understanding of how a product should perform, how we want it to perform. So we spend a lot of time thinking about, how do I want this material to act? Do I want it to be soft? Do I want it to be colorful? Am I mimicking something, or do I want it to be completely new? And so what you're looking at here is kind of an example of this.
Soft and colorful.
Soft and colorful, yeah, and it kind of varies. And so we can alter a material's performance. We can alter the feel of a material by changing its geometry.
Well,
so you'll see.
we've talked about that before
We have,
with the hockey helmets, I think
Yeah.
it was,
And
right?
we
The
actually-
padding inside?
We have some NFL helmets here too, which are really exciting.
Ooh,
Um,
okay.
And what we do is we can change either the geometry of an object. So here we have these very thick struts,
May
and
I?
that gives you, please.
Okay, so nice. Oh, yeah.
Pretty robust.
Yeah.
And so you're looking at something that's going to be pretty high energy rebound, but also relatively stiff for an elastomer. And so we have a couple of levers we can pull if we want to control the response of this material.
So can I ask, are these levers automatic?
Yes.
Oh.
So we have all kinds of automated software, and this is kind of the fun part. When you have a product like a shoe, for instance, like the
Wait,
ones
like a
like
shoe?
a shoe. Wow, that was impressive.
Come on, bring it up, bring it up. Come on.
I don't know if I can do that.
Come on.
I can do it.
There it
we
is.
go.
There it is.
So when you have something like a shoe, you want to know how the material responds, right? And so we run tests on the material to understand, how does this material react to stress? How does it react to strain? And then once we have that information, we can then create pucks where we have firm, getting softer, and then marshmallow mode.
Very marshmallow. I love the idea of the pucks, though, because you have, in order to judge this properly, you need some sort of standardization within the parts so that you can accurately judge it.
Yeah.
And the puck is a great example, not just because it's a standard shape that you can then pull levers on to automatically create the different structures, but also like you can touch it, you can feel it. Like it's a perfect example of how to.
Sort of like a dog bone for an
Kinda,
elastomer.
yeah,
like
yeah,
you
I
have
get
kind
it,
of an
yeah.
understanding of how this thing works. So we actually have an example. We have some bike saddles here.
Okay. Ooh, that's a great application for this.
Yeah. And so these
I've ridden a bike.
and then you may have we should get you one of these. You should ride one of these.
That seems better. Oh
this
my
goes
gosh.
on the bike. And
Right.
then it makes the bike more comfortable. It's great. So these are different zones. We have different strut thicknesses in one model. So the idea here is, instead of having something that's uniform in response, here we have nice firm spot on this saddle. This is by Physique. And then in the back, it's much softer. And so you can sort of
It's
reduce,
the same material,
it's the same
Andrew.
material. It's one print. It's one print. The whole thing's printed in one piece.
When we talk, I'm sorry to interrupt, but when we talk
Please.
about product design, anytime you have to create multiple feels, multiple texture differences, multiple abilities to handle different levels of pressure or stress or whatever, you're talking about different parts that have to be manufactured, that then have to be put into a product, and there's all sorts of issues along the way that can happen. And this is what's fascinating about this, is it's one print.
Yeah.
It's one material, and the differences are thanks to the levers that control the geometry.
This is great. You should do my job. This is perfect. This is exactly right. And so this is what we want. We
It
want
makes so
something-
much sense.
It does. It makes it easier for manufacturing.
Can I see
Not
that
worrying
one?
about, yeah, sure. And this one's in 2 pieces. And then we have a nice little channel in the center. And the idea here is instead of having to say, well, we need material A here, material B here, we need to add a skin through some kind of like overmolding process or, applying extra tape. Here we just print it in one solid piece, and then that's it. And these, by the way, what's cool about these are actually retail products. You can go buy these. These actually exist in the world. 3D printed style. I ride this one on my bike. It's great. It's really comfortable.
This would actually, it's just fascinating because I'm looking at this and it looks the same, but I'm like, this is, oh, that's soft. Oh, that's not as soft.
Yeah.
And that is from the printer.
From the printer.
Like that's not printed then assembled. It's from the printer
On the shell. So there is a shell.
Okay,
and that's
good.
A nylon shell.
Sure,
So we need
yes.
some rigidity. And so this is printed out and applied directly to the shell. We also have, we're going to keep moving on to some really fun stuff.
Ooh.
So,
Okay, so this is an Eagles helmet,
yes, it is.
and that is a Chiefs helmet.
Yeah,
Okay.
we know your football.
Did
This
you
is
bring
great.
Taylor Swift as well?
See,
How many people have asked you that already?
A lot.
Okay.
And having this like right front and center in the booth too, we're getting that question quite often.
I knew you were trouble when you walked in.
See, this is amazing. I am so focused on what's on the inside of the helmet.
I'm so sorry.
There's this on
I'm
the
so sorry.
outside,
I'm
and
so
it's
sorry.
like, oh yeah, that's right, that's a team, and people like the team too. But the 3D printing is the part that I get excited about.
Well, I do too. I do too, obviously.
Sure.
So this is an NFL helmet.
Yeah.
Like NFL is utilizing additive manufacturing to keep the players safe.
Yeah. So next time you're watching a game on like a 4K, 8K, million K TV, look really carefully when they zoom in on someone's face, and you'll usually see a little hint of lattice in the cheek. And so we have the Riddell and Vices helmets, and these are both used. They're custom scanned. So we'll scan a player's head to create the geometry on the inside. And that's how we create this conformal lattice on the inside of the helmet.
So then, okay, that begs the question then, if player scans create custom geometry, have you had feedback from players? Oh, this is great. Oh, this is wonderful. Oh, I love this.
We have. So there are ratings released every year that show what is the safest helmet, what is the most comfortable helmet.
Yeah.
And these 2 particular helmets are consistently at the top.
The Chiefs and the Eagles?
The Riddell and the Vices.
Okay.
I'm assuming these are both good teams. I don't know anything about the NFL. I'm learning though. I know that this one's very popular. People really like this one right now.
Yeah. A recent pop star collaboration with a player has, I think,
that's my understanding.
made that better. But that's fascinating.
Yeah,
that's
of course.
absolutely fascinating because this is the promise of additive.
Absolutely.
It's being able to faster, better, cheaper, all of those ticks,
Custom.
Custom, all of bespoke, all of those boxes that you have to tick with a check mark is starting to be checked in products, not just, hey, I made a retail product and it's on the shelf, but like the NFL is a big organization,
Yeah, of course.
and being able to keep their players safer with custom things.
Yeah. Exactly. So
That's awesome.
it's great. Yeah. And so what we want to do is we want to learn more about how these things are used in the market. What are the levers that are important? And so that's where we get a lot of these geometry dependent applications where we're making specific geometries and we want to understand, do we need to make things softer through the material? So these materials here, our new EPU 46, we have 46 and then we mix in something that makes it a little bit softer to make 46 soft.
Can you
And then
say what it
even-
is that you mix in?
It's called Part C. So you have Part A and Part B. So like it's a 2-part resin.
Okay.
And then Part C, now it's a 3rd part. It's pretty.
I didn't know it was that simple.
It's pretty straightforward. I know.
It's like we're a cooking show.
I know. We have a really big materials team, and they do a ton of really great work. And then they asked me to explain it, and I'm like, well, you've got these 3 bottles, and you kind of mix them until the ratio calculator says you're good, and then you're all set.
There's one way to bake a cake. You take Part A, Part B, and Part C.
And then you put it in the oven, and you're done.
Then you're
good.
done.
And
Then you're done.
Cross your fingers, and then you're done. But yeah, so we're trying
This
to
is
understand
so
this. Like, do we
cool.
want to make things that are, custom? Can we solve these problems using changes to geometry? Can we use our lattice generation software to make a lattice that really feels like a piece of EVA foam or feels like a piece of, solid material?
Right.
And then from there, can we make it custom? Can we make a workflow that's robust? And that's the promise of 3D printing, right? That's the future.
This is exactly. I've talked about this for a long time. People always ask me, what's the next greatest thing in additive? And I've shouted from the mountaintops, it is materials.
Yeah, absolutely.
It's materials because you can have a machine that prints fantastic, whether it's FFF or whether it's a resin-based or, or a metal or whatever, but you have a machine that prints great, and the advancements come in the materials. Like eventually we'll be 3D printing on other worlds to build homes and stuff, and the machines will be there, but it's going to be the materials that are the advancement that let us do this.
Yeah, like there's a giant walking robot here that's
Did you see that?
Yeah, spitting out concrete like a regolith, so that's going to be the future. Our printers aren't quite that big. They're big enough to print a bike saddle, not a house on Mars.
Yeah.
Yeah.
But would the house be this, or would it be this soft, or would it be?
You could do a mix of the two. You could do a mix of the two. So so this is the idea, right? We want to understand, is there a future for these custom projects? And so when you look at things like this, it's easy for me to think, yeah, absolutely, this makes perfect sense. I want a bike saddle that's custom to me. I want a shoe that's custom to me. I want a helmet that's custom to me. And I want those things to be made with this additive process.
Well, and really for you, it's a target-rich environment with soft things that protect the human flesh.
Yeah.
So bike seats, helmet linings, like shoes, anything that's a soft, squishy thing that makes us more comfortable. That's your bread and butter, man.
Yeah, absolutely. Yeah, so this is a small example. We have a big wall full of, we call it the retail wall. It's full of consumer products, everything there. Most of the stuff there, I should say, has price tags. We just kind of leave it on.
Sure.
Just to show like,
what's a product? It's got a price tag.
Yeah, this is exciting. I've been in additive for a while, and it's always been, the advancements in materials are exciting. But when you see something where this is like a real product, it's a very interesting experience. It's a weird experience to walk into like a bike store and see a saddle on the wall and say, hey, I see layer lines. I'm pretty sure this is 3D printed.
It's been, okay, remember back in the day, I'm almost off my stage here. Remember back in the day when websites were first a thing? Like I remember very vividly the first time I saw a commercial on TV mention a website.
Yeah.
And, for my generation, that's one thing. I think I'm older than you, right? A little
Sure.
bit? Okay. But I'm sure you remember certain things like
that
that.
too.
But everybody now that's a fan of additive remembers the first time they've gone into a store and they've seen an additive manufactured part on a shelf.
Yeah.
Like it just makes you feel good inside. Like this is the future we were promised.
100%. It is a weird feeling to go to a sporting goods store and just buy a pair of shoes that were made with a 3D printer. And it's like, oh, hey, that's the thing. We've been trying to do that. And like, we're doing it. We're actually doing this now. And then seeing it continue to expand and grow. That's obviously where I'm passionate about. I'm on the application engineering team at Carbon. So I spend a lot of my time thinking about how do I take something that exists right now and make it better, make it faster, make it cheaper, make it more capable, and do that with 3D printing.
Can we talk about that for a second?
Yeah.
Because application engineer, I'm going to be honest with you, fairly generic term.
I know.
When you're actually changing the world. But as an application engineer at Carbon, I want to take out the Carbon's great.
Yeah.
I love the company you work for. But let's take it out. But as an application engineer in the additive industry,
Sure.
What sort of mindset do you have when you go about finding a problem to solve? What do you like? Do you just walk down the street and you're like, hey, or do you have like a notebook of ideas, or what's going on in there?
It's actually really simple. So I think of my job as very simply, I take what a customer wants. I talk to somebody and they say, I want to make glasses and I want to print the nose bridge on a glass and this is how I want it to feel. And I say, okay, this is what you want. This is what's currently possible. And my job is in this little area in between where I say, let's see if we can make this work. Let's see if we can find a way to take your vision and marry it with reality.
You're a connector.
Yeah.
You take the wires from either side and connect them in the right way.
Yeah, and then you iterate on it. You say, okay, so for your specific application, I'm going to engineer a solution. There's the title. And so that's the basics of it. And it's so fun because every day is different, right? So all of these things are totally different industries, and you could easily spend a career or a lifetime focusing on any one of these. And I'm really lucky in that I get to work on new stuff all the time. So people come to Carbon with all kinds of ideas.
It must be fascinating, just like your job is new every day.
It's like a fire hose of, here's my idea. And it's like, great, let's focus on this. Let's make this real.
Okay, well let's pretend it's a day. Like it's a Thursday morning for you.
Sure.
Talk to me about what you do.
So I'll walk you through some of it. So I'll get an example.
No, it's Thursday morning.
It's Thursday morning.
Do you work out a little
Like, I
bit?
gotta
Get
get
a coffee?
Yeah,
Okay,
like,
you get a coffee.
right off
Good.
the bat. Like
Okay.
that is the most critical part of the day.
Okay. Can Carbon
nothing happens.
solve any coffee related?
We have a really nice
products?
espresso bar.
Do you really?
Yeah, yeah.
Okay.
It's nice.
Okay, good.
Which works out great. So the first thing I'm thinking about when I'm coming in is there'll be a package on my desk of a material. Somebody will cut a sheet of foam out and say, hey, I want to understand this foam. I want to characterize this material because I want to use it in an application. And I want to understand, how does this work? How does it react to stretching? Does it deform? How well does it react to pressure? What happens if you light it on fire? And these
Do you
are
get
all,
to test that?
We have a guy who does that, and it's very exciting, but also very scary. He's here too. You can ask him about it.
There's a guy at Carbon whose job is just to set things on fire.
Yeah, he did it with the Adam Savage print. Actually, there's a video of a little Adam Savage roasting 3D printed one. It's wild.
That's an amazing job.
I watch from safe distance. I get to
Sure.
appreciate
Sure.
all of the fun, none of the risk.
You say a safe distance just publicly.
It's
but
like 2 feet away.
yeah, I was going to say. Yeah.
So we're trying to understand the material, and then from there, my job with these pucks is to say, okay, let's see if I can move those levers. Can I adjust the geometry? Can I make something using our software that's going to mimic this material? And then more importantly, in additive, it's a really common request. Can you make something exactly like this material? Can you make something that functions exactly like my thing?
It's understandable.
It
Like that's like people. Okay, I don't mean to interrupt, but
Please.
that's like the people that try to make a steak that isn't meat.
Yeah.
It's like I understand why you're doing that, but there are better ways to go about this. And correct me if I'm wrong, but approaching you for an additive solution means you're going to find the best way for a material to solve a problem, rather than for a material to conform to something that solves a problem.
Exactly.
Okay.
You would never look at a stapler and say, man, this thing is too expensive. I'm going to make my own stapler. Stapler is going to be a pretty difficult thing to make from scratch. So instead, the basic idea is, okay, so let's take this material and let's understand what is the problem that it's really solving. And then from there, that's where the value comes out. Can we make it thinner? Is the reason it's so thick right now because the material is really soft? Can we make it thinner? Can we make it more colorful? Can we incorporate multiple materials into a single print? And then from there, it's feedback, it's iterations, it's working towards a solution. And then eventually, if everything goes right, you get to see the final product.
Oh, you know, you mentioned color, and we don't have a lot of time, so just a couple more questions. But you did mention color, and I don't think people necessarily realize how important color is to the engineering process for a product. Am I correct?
Sure. Accurate.
And I also, I don't think people really realize how soft this is.
I know, marshmallow.
It's so comfortable. Like it's purple. I want to sleep on it.
Like
like
exactly.
a mattress, you know?
It's like the perfect pillow material.
Do you have pillows?
Maybe. So the idea here with these colors, like, again, this goes back to the application development, right? If we offer blue, if we offer red, odds are a company's going to look at that and say it's close, but it's not our red, or it's not 3D printing nerd blue.
Okay.
So how can I make 3D printing nerd blue? So this material as a platform, we encourage customers, we encourage our partners to experiment with the coloration. So we provide all the tools they need to design their own color. Yeah, so these are examples of sort of stock demo colors, but we really want to encourage that experimentation because blue is different.
It's
too
different.
Too light, right?
It's
we want
too
to make
light.
it darker.
It is not the proper
we got to
blue.
fix this, right? And so that's the iterative process. And then we find one that works, and then that's the product.
Before you guys wrap up, can you show the inside of the helmet one more time?
Oh, yeah.
Inside of the helmets.
Hey, while we're doing this, Andrew, one more question. You've been in additive a long time, and it was with 3D
Central.
3D Central.
Yeah.
Thank you. But what a lot of people may not realize is Andrew started out on the consumer side of 3D printing, using consumer machines and making product that he could sell at a retail shop. And now he works next to a guy that sets things on fire for a job and plays with squishy things and tries to figure out the ways that additive can solve certain issues better than the way they're currently solved, right?
Absolutely.
And so I think could you take a couple seconds, just let people know it is possible to work in this field using experience in the consumer side?
Yeah, absolutely. It's not just possible, it's encouraged. So industrial 3D printing, this is a field that needs people with experience. This is a field that needs people who understand how these machines work and who understand how to solve these really complicated problems. And so when you're at home using, an inexpensive desktop printer to make a pencil holder or something, and you're thinking like, oh, this isn't transferable, It is absolutely
100%.
transferable.
100%.
The CAD skills, the material science knowledge, the understanding of the motion system of the printer. These are all skills you can carry with you and develop. And so, industrial 3D printing, it's a really great field. I've been doing this for a while. I plan to keep doing it for a while.
You look like
longer.
You're having a lot of fun.
I am. That's like the comment I always see on YouTube is like, this guy seems way too happy, and it's like, trust me, I am. Like, this is great. And it's because I get to take that experience and bring it in. So yeah,
dude. Thank you so much for bringing all this
Thank
wonderful
you.
thing. Andrew Sink from Carbon, everybody. If you're at home, give a round of applause there.
Thanks for tuning
There
in.
we go. There we go. You got a lot of stuff to take off the table.
I do.
I can't really help you there.
I can carry like some of it.
Hi, Dad. I know you're up watching. Just want to say hi.
Hi, David's dad.
Yeah.
Hi, Dad.
E3D is next.
Okay. Well, that was a bunch of fun.
Hey, yeah.
How we doing? Here we go.
We've passed like so many times.
Can of bikes.
Are you
How
going
about
up next? Are you
3D
gonna be
printed
on?
bike helmets?
Okay.
That's a great idea. Obviously, if they can do the
I saw the diamonds.
protection
I'm
squishy
excited. I wanna learn
parts
more. I
within
gotta
an
learn
NFL
more.
helmet, they
Good.
can
Did it go
definitely
good?
do it
Was that
within
good?
bike helmets.
Yeah, good.
I know they've shown hockey helmets
The comments
before,
were good?
so
Okay. I'm
it's
always
just
worried
a
about,
matter
like,
of
the
time by
comments.
this point.
The concern is always the comments.
Balu,
are like,
this
what
guy
is
is way
guy
too
so
happy, like
excited?
on cue.
And it's trolls. And it's
I love it. I love it. Andrew Rogers with Andrew is the best. Well, Andrews are pretty
Joel,
good.
he makes it easy.
Wouldn't you
He's
say?
He's
I don't know. That's how it is. Just scrolling back here. Can I have back support for my bus seat?
Oh, I see my
Maybe. Uncle Jesse. Heck yeah, Andrew. Sink. That's for sure. Oh man, this is going good. Well, how are we doing over there?
Well, I forgot he was live streaming.
Oh yeah, everybody gets to hear the conversations. Yeah, everybody. Other mic is hot. Other mic is hot. Other mic is hot. So there we go. Well, we're getting our next guest mic'd up right now. I really hope you're enjoying this look from Formnext 2023. Obviously, usually I'm broadcasting from the U.S. West Coast, which means it's not this early for the U.S. West Coast. I know we started, I believe, at 9 a.m. East Coast time, which is 6 a.m. My alarm usually doesn't go off until 7 a.m. Oh, I'm going to wet my palate really quick. We got 3 hours of talking, so I'm going to make sure.
You ready, Joel?
Sure. Here you go, Peter. Oh, my next guest is my friend Sam from E3D. Come on up, man.
Hey, Joe.
How you doing?
Hey, man. Nice to see you.
Nice to see you. Look at that name tag. Wow.
Is that-
Extrusion System Experts.
That is us.
And is it an NFC?
That's our new fancy business cards.
Can I scan it?
Please do.
Will it? Do I probably have to
I
turn
think
my
you need to
phone
unlock
on?
your phone, and then
Okay. I'm gonna do it.
yeah, we got
Yeah.
it. It's thinking. Oh,
Oh, there it is. There it
we
is.
go.
Open. Look at that. Oh man, I want one of these.
Neat, right?
Look at that. There it is. There. Wow. Email address. Add to
I know.
contacts. That's pretty fancy.
It's not too bad, is it?
I hear you've got something else really fancy.
Yes.
Tell me about it.
So we are super excited to finally be able to show everybody Revo Roto. So this is our
Revo
new
Roto.
Revo Roto. Cool name, right?
Well, no handbag manufacturer, I think, is going to take it from you.
No need, Joe.
Oh, here we go.
Oh,
All
I
right, Peter's going to.
apologize.
No,
You
don't
missed
worry about
every
it. You know, you've had an exciting time at Formnext already,
have.
announcing the Revo Roto.
Yeah.
So, I'll hold it still while you give everybody an explanation of what this is.
Perfect. So this is our new featherweight extruder. So what we wanted to do is keep all the same performance that you would expect from a E3D extruder, like we have with the Hammer XS, but really shrink down that package size.
Really shrink it down.
Really shrink it down. So for those at home, this weighs 140 grams.
140.
140.
Okay. So what is that? What else weighs close to 140 grams?
Well, I did a bit of searching about 3D printer parts as something that would do it, and I didn't find something that was 140, but an X-axis motor is 280.
So like a NEMA 17.
NEMA 17
that NEMA
motor.
17. Okay.
Half of that is your entire extruder.
Like extruder, meaning you've got
Yeah, so
like the extruder. This is everything.
it's an integrated extruder, meaning that there is a heatsink on there as well, which, if I do say so myself, is a pretty damn cool heatsink. So
Wait a minute. That's it.
This is it, yeah. Sorry, yeah, there's nothing more for me to bring. A fan would go in the front, but I wanted to show everyone.
That makes sense.
the heatsink,
Okay,
you
yeah,
know?
okay.
Yeah,
It's a beautiful design.
it is. And for those keen-eyed people on the live stream, will have noticed that is actually a 3D printed heatsink.
Yeah.
So we 3D printed a metal heatsink. So
Wait,
it's now
wait. Did you print it?
No, sadly not me. I don't have a machine.
Okay.
But we've got a partner that we've worked with in the UK, and so they printed that.
Okay.
Based upon our designs. But what it's been able to do is take advantage of all of the design flexibility from 3D printing, which means that like this geometry, you just couldn't cast on. Well, you could machine it, but the price would be astronomical.
Well, and the person machining it would be really upset with you asking to do this.
I have asked people, and they were very upset. But yeah, so you got a prototype, right? So there's a few cool features on here.
Okay.
I don't know if am I.
Yeah. Well, here you take it,
I'll
Peter.
try
You
and
on this?
try and
Okay. Here we
explain
go. Here we go.
So around this section here, we have some really tightly packed fins, and they go 360 around the heat break zone. So similar to what you'd expect from a turned heatsink, but we can pack them in really nice and tight compared to if you're trying to mill them or cast them from die casting. Then you've got the skeletonized structure in the front, which is good for whipping out any excess heat. But the really cool one, which is not obvious at all, is when the airflow comes through, a very small amount of that is actually filtered around here and back out of this little gap there. Like
Wait,
that.
real? Oh.
Yeah, so that's not
Wait
just
a minute.
clearance gap.
Wait a minute. That's tiny.
It is, but it's all that's required. So a very small film of air goes across your heat break section.
Yeah.
And so what that means is when we're trying to make a heatsink as efficient as possible, the obvious route is to increase the surface area, have more airflow going over it.
Yeah, of course,
like
of course.
The one that is often overlooked, but is just preventing the heat from getting into your heatsink.
Sure. Yeah.
Your heatsink has less work to do if it's not trying to dissipate as much heat.
But
So-
you can, if water's pouring into the bucket, you can either empty the bucket faster or just turn off the water.
Exactly.
Yeah.
Right?
Okay.
And so that provides a little shield, so that when all of the hot air is coming off from your heat core, it just helps stop that getting into the heatsink in the first place.
But you've tested this, like it's super effective.
Yeah, it is. You've done loads of practical testing, as you'd expect. But obviously, this all started with some really fun safety, some days back in the office. But yeah, so to put that into context, this is the most thermally efficient heatsink we've ever produced.
Okay.
Like beyond any of the 10 heatsinks, anything like that. So we have tested this printing PLA in an ambient temperature of 40 degrees.
That's warm.
Now we don't recommend you do that.
No.
Because like just everything else in your printer is having a bad day if you're doing that. And you shouldn't be able to do that with PLA. Like it's just unheard of in terms of how hot that was. And the other sneaky thing that we'll start to segue onto is we've added a load of sensors into this.
Oh, really?
So that is a grub screw hole there, and then slotted in there you'd find a thermistor.
Okay.
So when we're doing that testing, we're able to monitor the heatsink temperature whilst we're doing it.
Oh.
And it only had a delta of about 5 to 6 degrees, which is nuts,
Really?
right? It's mad. So it just kind of highlights how efficient that design is. So yeah, we're super pumped on that.
That's really cool.
Yeah, and like E3D's like ethos is to change the way human manufacturing. Wait, 1 second, I've got this. The pressure.
You got this.
Got
you
it.
got this.
It's to change the way humanity manufactures goods. We believe that 3D printing is the future, and as such, we should be using 3D printing more and more and more in newer use cases.
But you've proven that with this because this is
Yeah.
your very first 3D printed heatsink.
Yeah.
Or I'm sorry. Yeah.
Yeah,
Your
it is
heat
a heat
sink, right? Yeah, heat
Yeah.
sink. Yeah. Okay. So you actually used additive to solve a problem
And make it better at the same
and make
time.
it better,
Yeah, which is like the whole.
and make it custom
Yeah.
for you. Like that's perfect.
Which,
Look at that story. That's
I know.
wonderful.
Yeah, it's awesome, and it's not the only place. So there is also an integrated filament sensor, which is this object on the top.
Okay.
And that is an MGF housing. So again, 3D printed.
All right.
Getting it in everywhere we can. So this also has a programmable action button. So this sort of thing there.
Oh, I see.
So you can press that, and then it will run a macro on your machine.
Oh, so it's just like a G-code macro sort of thing.
Yeah, but
Okay.
it unlocks so you can, on my personal machine, I have it set up so when I press that, it checks if it's hot. If it is hot, it unloads. If it's not hot, it heats it up and then unloads. Some of the other guys have it for just like preheating the bed, or like there's loads of things you can get it to do, and kind of cool to see what people are gonna do with it, because
Well, it's a programmable button. Someone's gonna make it call their mother. But just when you talked about it, my first thought was it would be amazing if I wanted to unload filaments. I just had to hit a button, and it knew what to do to unload it. I didn't have to go through a menu and do something, and
it's easy.
Like it could unload a button and then send a message, and I could get a signal thing saying your printer is ready, and then I could go there, load filament, and be good to go.
Yeah, exactly. There's countless ways you can integrate it. And then speaking of filament loading, it's a pretty cool idler we've got rocking here as well.
Ooh,
so,
okay. Oh,
I'll try and get it. I don't know if that's in signal. So,
is that good, Peter?
Ian, perfect. So this is a flexure arm there.
Okay.
So it's a bistable idler, meaning that in its current position, the hobs are engaged with the filament, so it'll
This is the printing configuration.
The printing configuration.
Okay.
Yeah. Then you simply grab, pinch, and then it's held. And so that has ridden up over a ridge that we have printed into the printed heatsink. I don't know if I mentioned we have a printed heatsink on this thing. And
just a little ridge right
just
there.
A ridge, yeah.
Okay.
And then that holds the hobs away from the filament, meaning that you can then just manually put them in out. So it's all with one hand. So like with the Revo nozzles and the one-handed nozzle changes, that kind of like kickstarted trying to make our products as user-friendly as possible.
Well, I've heard from a lot of people who might not have the same abilities as you and I.
Yeah.
It's a lot easier to use their 3D printer because they don't have to use a lot of tools.
Yeah, exactly. And the same is with this. And so, yeah, you can unlock it with one hand. And then if you want it to re-engage with the filament, you just pinch these together. And it just pops
And that's
back.
it.
That's it.
Just like that.
Just like that, yeah. And for anyone who might have any concerns about the longevity of this, we made a test rig at E3D that poor life was just pushing it one way and then pushing it the other way. But that got to 16,000 cycles, which we decided was sufficient because that's about.
Oh, it didn't break at 16,000. You were just like,
oh no,
this is done.
Well, actually, the machine decided it had enough, and one of the arms on the machine broke, so it outlasted the test rig, which I thought was quite cool.
That's fascinating, right there.
And that's something like I think it's one filament change every day for like 40 odd years, 48 years or something. So it's gonna last.
It's gonna. There's gonna be some people doing that.
I
but
mean,
that is a really a testament to what you say here, right? The extrusion system experts. It's not that you were so smart. Thank you, David. It's not that you were so smart. You've learned along the way and evolved your products, evolved your process to come up with this. Being so lightweight, I wanted to ask, like when I think of lightweight extruders, I think of Delta 3D printers just because that head wants to fly around. A lot of times they go Bowden because it reduces weight, but I mean, you could have a direct drive Delta fairly easly with this.
Yeah, definitely. I mean, when you look at a lot of the Delta machines, there is a surprising amount of mass in those hot ends, not hot ends, sorry, in those like carriages, because of all of like the printed ducts and things like that, and so it does fit into that package. It does like open up the possibility of getting that precision from a direct drive extruder on a Delta. And then also for your higher speed machines.
Oh yeah, any of the
You know, the having a lower mass instantly means that you can put them up. A lot of the test rigs we have been running like 30, 40k axles, just like chugging along.
Really?
Yeah, with no worries.
Well,
it moves.
And you pair it with one of these, may I?
Well, if you want to pair it with one of those, because that is actually a high flow obsidian nozzle.
Really?
That's right. We've finally merged the two together.
High flow and obsidian.
Yes.
So I can print carbon fiber how fast?
Well, as fast as you can get your machine to go. That's a 0.4 one. So when your motion speeds end up creeping up into like 200s, 300s. So
okay.
Yeah, I mean, like for some of these options, these are no longer the limiting factor. It's how fast can your printer go.
Yeah, I mean, it's well, really, what you've done with this is you've now taken away some of the weight. Like you've made it so, can the printer go faster? Yes, it can now because of this. High flow Revo Obsidian.
I know, it's just stealthily added in, but yeah.
So you just put the little, the what is it? It's a 60-watt heater, right?
Yeah, 6-watt heater with the same as you would with the normal high flow.
Okay, and then put it on here, and then just zoom, like just zoom, right?
Zoom, yeah. There'll be more details in the coming weeks about that one specifically.
Okay.
So for those,
this is all new, announced here, right?
Yeah. So the Roto. So this is going to be available at the end of the month. Is when we're planning on shipping the units.
Oh, so can people pre-order now?
We're not taking pre-orders, but we have a website page, which I believe one of my colleagues is hopefully linked in the page below, which will take you to register your interest. It has a bit of a more detail, so if there's a few things I might not have covered here.
But if it's not there, they can go to E3D's standard website. Is there a link down to it?
Yes.
Okay, perfect.
And then you'll essentially just get an email as soon as they pop into stock.
Oh, so this, well, this could be in people's printers by Christmas.
Yeah.
That's
Cool,
really
right?
cool.
Yeah.
Yeah, that's really cool. You're not like announcing it and then 6 months later you're going to talk about developments and stuff. You're like, no, it's ready.
Yeah, no, we're not doing that now.
Okay, what about this one?
That one, I can't comment on that unfortunately.
Okay.
I don't know the exact timings of when
Soon?
that will be.
Ish?
Soonish.
Soonish, okay,
yeah.
sure.
I think I can commit to soonish.
Soonish, that covers like 6 months, 5 months, I think at this point.
Yeah.
Hey, Sam. This is pretty cool, man.
Thank you.
How much involvement did you have in the making of this?
So this is a project I've been running for the past 2 years.
2 years?
Yeah.
You've kept this secret for 2 years.
I know, I'm evil. Yeah. But no, it's definitely not just from me. There's been a massive help from all the other engineers and the commercial team and everyone back at E3D. So big props to everyone that's been
that's cool,
able to
man.
help us get to this point, really.
And if they're at Formnext or if they're coming to Formnext, they can see it in person.
Yes, so we have a few of these over at our stand. And another thing to mention, we've done a couple of partnerships, one with LDO and one with Duet for toolboards, so canvas toolboards.
Oh.
And we have prototypes of those here on display as well. So if you can have a look at those. And also Duet have a few of these with the toolboards. That's what I was just talking about.
Hey, he's actually mentioning it right now. Duet and LDO, yeah.
There must be a lag to over there.
Okay, ready, and go. What about toolboard options, Sam?
So we have 2 toolboards. There's one with LDO. That'll be a clipper-oriented one, and then another one with Duet for the rep machines out there.
Oh, I love both of those companies. Both fantastic companies.
Yeah,
well, I mean, and E3D as well. I love that. I love that this is 3D printed. I love that it's really kind of harkening a really fast, lightweight sort of thought about extrusion systems. And I love that you're working with Duet and LDO. I love it all, man.
Thanks,
this
man.
is really great.
It means a lot.
We don't have any more time, and so I just want to thank you for coming by here. This has been amazing. This is Sam from E3D, everybody. Look at that, you even got applause.
I know.
Everybody, well, here, I'll tell you what.
Thank you very much.
I'll tell you what, I'm going to give you a hug.
I love it.
Thanks, man. I really appreciate it.
Look after
And
yourself.
I will be by the booth at some time.
I look forward to that.
Soonish.
Soon-ish, yes. Thanks, man.
Have a good rest of Formnext.
Cheers.
Oh, look at that. Soon TM, soon-ish. I love it. Hey, Bill Steele said E3D nice. You guys got a fan in Bill Steele, so that's pretty good. You know, the first thing that Bill Steele is going to do is adapt the Roto to his Chameleon 3D stuff. You know that's going to happen. I mean, obviously. Oh, Ellie says congrats on the launch, Sam. 3D Musketeers, nice work, Sam. Neuro 3D with a clap. Oh, this is great. Formnext is just an amazing time. I really hope you guys can get here. If you're anywhere near Frankfurt, Germany, I highly suggest you find your way here. If you're not, you know, there are flights available. I'm gonna have some water. That's a really good idea. Perfect. Non-stop, baby, non-stop. Ooh, Z-Matcher looks perfect for a boron 0.2. Those tiny little machines like to go really fast, and putting a roto in there, I think would be perfect for that. Here, Peter, I'm going to give you that. Okay.
Are you ready for the next guest?
Yes. What's your name?
Tony.
Tony. Yeah. Okay. That's what. What? I know that. I forgot the name.
Yeah, that's all right. Yeah.
There we go. My next guest on the stage. Oh, come on up. Come on up. What the heck? Everybody, this is Tony from Maple Glass. Dude.
Hey, how you doing?
Good to see you.
I'm such a fan, by the way.
I'm a fan of you.
Oh, thank you.
That's just how it is.
I feel like we're going to be best friends. Hang on. Where's my glasses? There we go. Now we're glasses.
Oh, now are we? Well, here, you want to try mine?
Oh, yeah, sounds good.
Let's see. Okay.
Ah, perfect.
Yeah?
Yeah.
Oh, you look like me.
Yeah.
It's weird how that works out. Okay, there you go.
There you
You
go.
want to
Now we can
I need
both
new
see
glasses,
again.
as you can tell.
No, oh, same.
So, from Maple Glass, which is 3D printing glass.
Yes.
3D printing of glass.
Mhm.
Now you got a box here. Oh my god. Okay. First of all, I hope they can hear you over whatever's happening behind us.
Yeah.
The 3D printing of glass. Now, normally we talk about extrusion systems that
Yep.
extrude polymers.
Mhm.
And we talk about 215C,
Yeah.
290C for some nylons,
Yeah,
Peak
maybe.
and Ultim getting up to the 400C.
Yeah.
What temperature do we have to achieve for glass?
Glass around 900 to 1,000
C.
for typical soda lime. Yeah, so we're talking so hot that inside because we print in a annealing chamber, we can only see inside of it once it gets to about 750, 800 degrees, because it's so hot that it actually generates light, and then you can see inside of the machine. So we don't need to put a light in there.
Oh, that's
we
right,
just
because
wait for
molten glass is,
It's so hot that it just produces its own light. Yeah.
That's amazing. That is absolute. Okay. There's a box of parts here,
Yeah.
and we could continue talking temperatures, or we could look at some incredible
totally.
glass prints.
Yeah,
so
geez.
let's start getting some stuff out of this box.
I don't
What's
know
first?
what you want to do first.
No, you pick,
far
man.
out.
You run this part.
What about this guy?
Hey, I'm familiar with. Oh my gosh, it's glass. Like it's glass. It's glass.
Yeah.
What? That's so.
You know, some
it
people
doesn't
don't
make any
believe it.
sense.
Some people don't believe it. They say, no, this is a polymer, a clear polymer. And we've had to actually make a video of us putting a flame to it and then showing a clear polymer and putting a flame to that. PLA burns very, very easily.
It really does.
It really
really
burns
does.
easily.
Yeah.
So, yeah, we learned that the funny way. But yeah, we thought we'd print this on for you. This is 0.25 millimeter layer height.
That's just, that boggles my mind.
Yeah.
That when we're talking about printing of glass, which
Mm-hmm.
already doesn't make sense, you're able to control the layer height
Yeah.
down to
Yeah.
sub-millimeter.
Yeah. And we use a nozzle that is 1.5 millimeters in diameter,
Okay.
the exit. And
Now,
we
why
can-
is that? Why is that?
Well,
Why 1.5?
I mean, look, that's just our standard. We've played with bigger and smaller as well. We just kind of landed there because we can build kind of big-ish parts, or parts that are about this
Oh,
big
okay.
kind of quickly. So kind of a flow rate thing.
The nozzle size
Mm.
was so you could build appropriate size parts.
Yeah, pretty
Okay,
much.
okay.
But you know, like it's interchangeable. So we are really lucky because we get to be really selective in what kind of detail we print.
Okay.
Yeah.
Well, this is fascinating.
Yeah.
Like it doesn't, it's glass. Like if I feel it and I don't look at it, I'm like, okay, that is glass.
Yeah, but there's
there's-
something different about it because
There's
it's 3D printed.
geometry.
Yeah.
And it's 3D printed geometry.
Yeah,
and
yeah.
that's what just,
And it's a one-step process. It's not like we have to burn off a binder or do something else afterwards. That is exactly how that came off the print bed.
okay.
Mm.
This leads me to a couple questions.
Sure.
So first of all, I know how to load PLA into a machine.
Mm-hmm.
How do I load glass into a glass 3D printer?
Yeah. So we have an extruder system. Obviously, it's a little different to a just a little bit different. It needs to go quite. It needs to like grab onto an object, which we actually make our own filament. So yeah.
Do you even call it filament?
Yeah. Well, glass artists will call it cane or just I guess rods of glass. So
Okay.
unfortunately, we can't spool it, but basically that'll feed.
No, you
yeah,
can't.
I know. I wish we could, but
I'm sorry, I'm just
yeah.
really
No,
excited
no,
about
please,
these parts.
please.
Producer David over there is kind of jonesing to see these too. Look at
Yeah,
that.
yeah,
Look at that,
absolutely.
David.
The audience is asking.
Yeah, totally. So this is an architectural design. Obviously, everyone's familiar with the benchy.
Yeah.
And we make our own filaments so we can, use different colors. And this is all 100% recycled glass, which is really cool. It's all glass blowing waste from a local studio. We literally go. We've made friends with them. We go and just take their bin waste, basically.
Oh, but that's great
Yeah.
because it's something for you and it
Yep.
solves the problem of theirs.
Exactly. Yeah.
Now this one's got some blue in it.
Yeah. Yeah.
What
I
what
really like
makes
this one.
what makes this blue?
Right. So, I mean, the color that we put into the machine that makes the filament, we add a bit of blue to the clear waste glass, and then we can get like the kind of a blue
Okay.
core coming through.
Oh, so it's
Yeah.
like using a marker to color filament.
Yeah, essentially. Yeah,
Okay.
yeah. But it could just be solid blue glass as well. That's another option. Like that was solid red glass actually, and when you print it, glass is interesting. It can change color when you heat it.
Who knew?
Yeah, right. So that one turned orange, and I was like, oh, nice.
Have there been discoveries about glass because you print it?
Well, as a material, glass is being used for thousands of years, it's really interesting that after that time, it has only been really glass blowers will use glass and mold makers will use glass, and
Okay.
for thousands of years, it hasn't really touched any digital, innovations or advancements.
So Dale Chihuly is a glass artist, right?
Yeah, the name's familiar, but
He did.
Yeah.
I think he's based
Chihuly.
in Chihuly, based in Seattle, has a glass piece. He did
Yeah,
some of
yeah.
the glass sculptures in Vegas,
Mhm.
but still not a digital process.
Right. I mean, like there could be digital elements to it, like we 3D printed this, or the design was first done in a 3D software. But
You have Batman right here.
yeah, that one's 0.25 millimeters layer height as well. So really interesting. But yeah, in terms of glass innovations, it's really been a material that's been worked with in a very similar way for a very long time.
Okay.
So, being able to create parts from glass with no glass blowing experience or no mold making experience, no, like you've got the 3D printer, but you don't need to have like this wild background in 3D printing. Our first customer actually learned how to 3D print on our glass 3D printer. So
Wow, talk about hard mode.
Yeah, I know, right? We told him, you probably want some experience. He's like, that's all right. We'll figure
like,
it out.
nope. He's like, full
we'll
send.
do it. Yeah, and they make some amazing parts. So yeah.
So, okay, glass blowing and glass artists are able to make some things. And if I look at this, like these are artistic pieces, but I mean, the Batman doesn't have the top of his head, right?
yeah.
And neither does Mini Joel.
Yeah.
And this is a boat, but the boat, how is it still in its infancy? Like, are you okay? Because it does. Like I can imagine some things being made with it, but you're still needing to refine the process further.
Yeah, it's continually upgrading. Only like 2 and a bit years ago we commercialized the technology, right? And we that's when we released the Maple 2. So our Maple 1 gets reserved for the prototype. Maple 2 is our first commercial machine. We've got the 3 now that we sell. And the Maple 4 will probably come out soonish.
Really? Yeah, soonish.
Yeah.
Soonish seems to be a theme of this
Yeah.
of this stream here.
Yeah. So the technology changes quite quickly.
Yeah. What do you got?
Just let me know when you want me to get those off the box or get a piece on.
Yeah. Yeah, I reckon. Let's do
Oh,
it. Yeah.
sure. We
Yeah.
can take these. Yeah.
Yeah.
I guess there's another piece out there.
Yeah. So we're talking about art pieces and like kind of decorative stuff. Obviously, this is one application that's quite big, but another one is architecture. So this is a collaboration with RMIT University Tectonics Formations Lab. So they designed these glass pieces and then some of these plastic pieces to basically show off a small scale building facade element. So architects are really excited about our machine and how it might scale, and that's what our kind of next push is, going bigger.
Yeah, well,
Yeah.
bigger, obviously,
Mhm.
but and I like that this isn't when people make decorative pieces with a standard FFF printer. There's some that always shout, "You need to make a functional print."
Yes.
Glass, its functionality is typically
Yes.
its decoration.
Correct. Yeah, exactly.
So then
yeah.
this is completely functional print.
Mm-hmm.
Oh, I love that.
Yeah. So yeah, it always depends what you want from it. I mean, the glass world is actually quite small when you start to speak with artists and designers, and there's so much passion there for glass and it as a material, just for the sake of making something out of glass. So
Yeah, it makes sense.
it's always nice to feel that passion. As a mechanical engineer myself, I'm often taken back at how awesome people in glass are. Yeah.
You just giggle though, like you're a part of this awesome glass community,
Yeah.
and you're using a machine,
Yeah.
like mechanical
Yeah, yeah.
engineering to make glass art.
Yeah.
Do you, in the cosplay world,
Yeah.
some people think that 3D printing is cheating and it's not real cosplay or real art. Are glass artists hesitant to call what you do art?
That's interesting. I think some people, yes, would have hesitation. If we had to define any technology, though, there's so many technological advancements that allow us to even hand blow, to glass blowing. The gas system, that the furnace, all the tools, so. Yeah, I think this is like another tool that allows for creative expression. If you just printed the same design over and over again, maybe you'd lose that creative expression. But if you use the tool in a certain way, it's kind of how you use the tool, right?
Well, I mean, but to be fair though, there are mass-produced glass things that people think are a creative expression still.
Right.
You've just added a new type of manufacturing to
Right.
glass making or glass blowing or whatever. Glass working, I guess. I don't know. That's kind of how I think about it. One of the things I wanted to ask about, and it's because it just happened.
Oh no!
So I've got myself a tiny little glass splinter.
I'm sorry.
Oh no, I'm pretty resilient. You don't get to be this old on Earth without having a little bit of resiliency. Like I get it.
Sorry.
No, it's.
Where did that even come from? Was it?
Well, it probably came from the glass I was handling.
Maybe.
That's
Just a guess. It wasn't your.
But I'm
glasses?
wondering, like, what are the dangers that you have with being able to 3D print glass? Because obviously you're working with temperatures that will burn you.
Yep.
And you're working with material that can hurt you, and it can be sharp in certain forms.
Totally.
I'm not worried about this, but
Yep.
this does bring up something interesting.
Yeah.
Like when you and your coworkers are doing this, what precautions do you have to take in order to make this safe?
Yep. So it's an interesting one. So the nozzle gets to 1,000 degrees, but it's enclosed in a furnace, so it's kind of blocked off.
It's still hot in there.
It's still hot, right? Yeah. So provided we wearing our PPE, which we always do, then we make sure that we kind of distance ourselves from the heat. What's interesting is I've hurt myself glass blowing, but I haven't hurt myself 3D printing, and I 3D print glass a lot more than I glass blow. So it's kind of like you're kind of like protected from the hot zones because of the furnace. So obviously, if you use it the right way, it can be quite safe. We make sure that we got the ventilation on and all that sort of stuff to make sure, when things get hot, you're not breathing in any fumes. But
That's good. That's good.
It's non-toxic, all this glass that we use. We're not using like lead-based glass.
Right. There's no off-gassing of this weird stuff that you shouldn't breathe.
Yeah. So we make sure that we do everything, as safe as possible. But glass blowing is probably a lot more dangerous than 3D printing glass, because once you hit print, you actually step away from the machine. You don't actually.
Oh, it is an automated process.
It's fully automated. So, whereas when you glass blow, you're holding onto a metal rod that just on the other end, it's like 1,000 degrees or even higher. So you can easily just put your hands in the wrong spot, and it's probably safer in a lot of ways.
What's that? Oh, question from the audience. What do you got?
Can you print with borosilicate glass?
Oh, borosilicate. So can you print with borosilicate glass?
Yes, so we haven't done it yet, but we know that it's possible. Our nozzle, our heated block that we produced is only using 5 times less power than a hairdryer to get up to 1,000 degrees. 5 times less power than a hairdryer.
5 times less.
Less.
Okay,
yeah.
so A hairdryer is using
like
I think 1,000 watts.
1,000, 2,000, depending on the
1 to 2,000 watts.
Yeah.
Okay.
Maybe our hairdryer uses 1,000 or something
could be.
like that.
You're
And
down in
then,
Australia,
my-
right?
Yeah.
Yeah. So I know everything's different down there, right?
Yeah. So,
Really though, but 5 times less. So we're just talking a few hundred watts.
yeah, a few hundred. Yeah.
That's just a couple US light bulbs at that point.
It's not
nothing.
It's nothing, and it's really well insulated. So when we first designed the machine, we thought someone would be able to make this heater block for us. No one that we asked for could do it because we wanted it to be not 240 volts. We wanted it to be 48 volts. So much safer.
I see. Yeah.
So everyone was like, "Why don't you just make it 240?" It's like, I don't want it to be 240 and exposed to, So we had to make it ourselves, and at the time it was a bit frustrating. But when we started producing it, it was good because now we can make different heater blocks for different temperatures. So we can go to Boris much higher if we want to, by just slightly upping the power and changing how we make it.
What would being able to print borosilicate glass offer as a benefit?
Right. So I think in the medical and a lot of research areas like chemical areas, they use borosilicate glass for its resistance to like shattering and stuff. Properties higher temperature, so they can hit it with flames and do reactions and stuff like
those prints could be put through an autoclave to make it clean again, right?
Yeah.
Okay.
Yeah, totally. So there could be a lot of new applications. What's also great is we make our own filament. So
it's weird that you call it filament.
Yeah,
I just want to say that because filament is all bendy.
Yeah.
I don't know. It's glass filament.
Paint,
like it's filament.
Yeah. Filamento. Yeah.
Glass cement. Glass cement.
Glass cement.
No,
we'll get there.
Yeah. Filament with a silent G.
Yeah. So what were we saying? Something about
borosilicate and the
right.
healthcare industry being able to take advantage of things.
Mm-hmm.
Yeah. Your printer, if it could print that and get that high of a temperature, then
So printing different materials because we make the filament, we could print a whole range of materials, even composites, glass with say metal powders or ceramic inclusions, or I'm a mechanical engineer, like I said, not a glass expert, but if we connect with the right people, who knows where it will go in 5, 10, 20, 30 years.
Well, even just 12 months down the road, things could be completely different.
Totally,
24 months down the road, you could have Maple 4, Maple 5, Maple 6. It's really exciting to think about because right now you're just using waste from glass blowers. But it's not that far of a stretch with Formnext being about sustainability, being able to use recycled glass, or if companies that take glass in for recycling can utilize your technology to refine it a different way, or something like that.
Exactly,
I mean, you're sort of heading in that direction.
So we've printed with beer bottles, wine bottles before that we've melted down, and we've done optical glass for various fiber optic applications. So there's not us, our customers, but we worked with them to produce the filament. So there's some really interesting applications this early on, and we get a lot of interest, in Australia, but also international, and it's exciting to see where it could go.
Oh, it's really exciting. Well, I'm really looking forward to not just the stories you have of people that you can help with the technology, but the people that can acquire your machines to do stuff, because you're going to hear about it all. You're going to have to keep me informed. I know we're running out of time, but I just want to say thank you very much. This has been an amazing time. We got to show. This is the first time I've seen printed glass in person, and I'm really glad that you were able to bring it out here.
Yeah, thank you.
And then I'll say.
I'm sorry. When was it? When you picked up this one?
Maybe. Let's see. I'm trying to see if I can grab it with a fingernail. Do we have a piece of tape? Like the. Yeah, that's true. It's just a tiny little splinter.
Yeah, sorry, buddy.
What? Oh yeah, I could dig around in there. Sure. That's what we want.
Yeah, thank you. Close that. That's good.
Next up is Arburg.
Awesome.
You'll have to give me a second. I really want to. Oh wait, I got it.
Oh, sorry.
I got it. Here we go. I just I'll save this tape as a memorial. Dude, thanks for coming on.
Man.
I really appreciate it. Everybody,
Awesome.
Maple Glass.
Thanks, Joel.
Maple Glass,
Cheers.
man.
Appreciate it, mate.
Oh, oh my goodness.
Yep.
Gerhard Grobler, I am back covered in rocket propellant. That's not a comment I anticipated seeing today. So thank you for that. That was amazing. I got a glass splinter out of my hand. I didn't think I was going to be doing that today either. You never know what's going to happen at Formnext. Peter's on camera. Peter, we good? Come around here for just a sec, Peter, real quick. Come around. Real quick.
Hello.
Everybody, this is Peter, Stargate Studios Malta.
Yep.
Remember the videos we did there? That was a lot of fun. Dude, running the camera here. Appreciate you, man. Wait. Okay, there we go. Oh, that was a good time. Okay, well, let's see. How are people doing? Javier Romano, live splinter removal. That's right. That's right. They're not going to leave the 3D printed Jolt. No, my guess is what will happen is they will refine the process and get me a proper 3D printed Joel. Am I right?
Yes.
Yeah, there we go. There we go. Yeah, that's what'll happen. Oh, people said hi, Peter. Creatrix Britt, do you need a medic? No, I solved it. And look at Britt said get tape or a credit card. I got tape. I pulled it out. I think I'm good. Oh man. Yeah, I didn't think a live medical process would be what I was going to be doing today, but you know what? You do cool stuff. It's funny. So real quick before we bring on our next guest, Peter over in Malta, while he knows English, he didn't know the term fly by the seat of your pants. And so we had to look it up and what it meant and how to go about things. And he thought it was really interesting. And it's just, we're flying by the seat of our pants with some things, including splinter removal. I think, are we ready?
Well, we're wrapping up a gift for you. You're taking home the glass Joel box.
I am, oh, the mini Joel is coming home with, look at that. It must have been the comments. It must have been all the comments telling me that I should take it home.
Yeah. Tell everyone I said hi.
Luke Boppart, Peter passed the vibe test.
Nice.
That's good right there.
You can let them know that's me saying hi on the. I'm running the chat.
Oh, producer David is on the chat. So I'm up here. I can read comments, but anything typed out, that's going to be producer David. So make sure if any 3D printing nerd typing comes up in the chat, it's David. Make sure you say hi.
We are ready for Sam from Arburg. Are you ready?
Sam from Arburg? Okay, well, here, let me give this to Peter.
Simon.
Oh, we averted disaster there. This is Simon from Arburg. Simon from Arburg, right? Please welcome Simon from Arburg. Hey, Simon.
Hi, nice to meet you.
It's good to meet you as well. Welcome to the show.
Thank you.
Now, Arburg, just look into the camera there and let people know, just kind of a quick 30 seconds. What is Arburg? Who is Arburg?
Arburg is a big company, well known for its injection molding machines, and Arburg Additive has different type of printers, FDM printers, also LIQ printer for silicon. And in my department, we are working with the freeformer, so we have a pellet-based 3D printer.
Okay, pellet-based. I love hearing about that because in the consumer world and even in a lot of the professional world, we don't deal with pellets. We deal with filaments of various sizes. And so being able to use pellets, what does that offer? What is the benefit there?
The benefit of pellets is also for a pricing point. So you have economical benefit to use the pellets, and also you have the direct material, which is well known in the extrusion or in the injection molding world. So, for example, you have an FDA approval or a food contact approval of most materials.
Oh, I see. So you already have that because pellets exist within the industry.
Right.
And so being able to use it on the additive side of Arburg means those certifications carry across in what you're doing.
Yeah, right.
Oh, okay. Now you've got some parts up here. Yep. I recognize the coloring here. Can we start with this one?
We can start, yes.
Okay. What material is this?
This is Ultim 1985, direct from the pellets.
Direct from pellet. This is Ultim from pellet. Wow. Right. It looks fantastic.
Thank you.
Did you make this yourself?
No. Engineer did it in the department. And it's also done with our new machine, the 750 3X in the high temp version.
Okay, high temp. So
high temp.
When printing with Ultim, you have to take into account the chamber temperature.
Yeah.
And you have to take, and you're working with pellets, then do you have to heat the pellets as well?
Yeah.
Okay.
You have also to pre-dry the pellets. It's also possible in the machine direct because we have a dryer in the machine. And then we have the extruder, 2 heater bands direct on the extruder side, and also 1 heater band on the nozzle side, so the discharge nozzle.
Wow, really? Okay. And but to be able to do that though, this is huge because the parts are perfect. Now, I mean, this is really a testament to the process that you have, being able to pre-dry and the number of heater bands you have around everything, because you want a very precise temperature to extrude at over time and a chamber temperature to be able to keep the part perfect. Because a lot of times on a part where you need to have a heated chamber, if you don't have it right, you'll have some lift, or you know, you'll have some warping or whatever. But there's nothing here. This is perfect. This is like an impeller blade or something like that.
A radial fan.
A radial fan. There we go. Oh man, it looks good. Peter, can you see that? Just look at the fins on that and how perfect it is. How long does it take to print? Do you know?
Roughly 48 hours.
Okay. As far as printing Ultim 9085 goes, is that a typical time for a part this size?
Depending honestly on the size of the part and also how many border contours do you have.
Ah, I see.
Also the amount of support you need, because we also use the corresponding breakaway support, also from the company Sabic, to print that part in that quality.
Okay. Oh, I was thinking you're talking about support. It's like you're not using Ultim for support, because that would it would weld itself to itself, right?
Yeah. Sticky clips.
Oh, but so then was breakaway support used on this?
Yep, on that
okay.
side we have a breakaway.
Because the undersides are really nice.
Yeah.
Like this is a good part. This is a really good part.
Thank you.
Okay, so Ultim 9085 from Pellet.
Yep.
Being able to manage that process all the way down to the completed part. And then you talked about the benefits that this offers. And are you, for that machine that does that, are you working as a bureau to provide parts to customers, or are customers buying the machines to make their own parts?
Customer buys the machine. We are a machine builder, but we also do give profiles, for example, for the Ultim 9085, that a customer directly can start with that profile and achieve that part quality in their facility.
Oh, I see. So then they're not just buying a machine, and you provide lots of support along the way to get them to perform as good as this is here.
For sure.
Cool. Okay, Ultim 9085. Well, you got other parts here. Tell me about these.
Yeah, we also have here a nice part, because what we did here is, in the past, it was not possible to have a reinforcement for fibers, because our nozzle and needle system would clog because the fiber was too big. So the ring gap was only 10 microns. And we improved that process, that we have a bigger ring gap so we can work with fibers. So we have a reinforcement in the part itself.
Okay.
This is a semi-aromatic polyamide with 25% glass fiber.
25%. Oh wow! You're not holding back, are you?
No.
That's a really good fiber load. Oh, and the part, and it's perfect again. So this is all a testament to how Arburg Additive is doing the material management on machine, right? Because for this is a PA, so then you're having to keep it nice and dry.
Yeah, exactly. And also this type was made with a soluble support material, so in that case a water soluble support material.
Oh, wow. Peter, I don't know if you can zoom in there and look at the undersides, but that's a perfect part right there. Well, it's amazing, because when we talk about polyamide, we're talking about a nylon. And anytime we have to print with a nylon at home, we have to have a proper extruder, and we have to dry it properly, or put it in the oven. You have to take the lasagna out of the oven and put the polyamide in the oven. You can print really good nylon parts, but it's a lot of management on the material side. And you're just like, no, the machine takes care of it. I hit a button and this comes out, and it's got soluble support, water soluble support, and it comes out, and it's like, that's really cool. That's really cool. But really quickly though, the people that like to print nylons, as an example, at home, the experience and the knowledge to do that does transfer to jobs in the companies that own your machines, I would imagine.
It is.
Okay, good.
For sure.
Okay, so we got our Ultim 9085 part. We got our 25% glass fiber loaded PA right here. You're on a roll, man. What's next?
I like this one really a lot, because here we have an insole.
Wait, this is printed?
This is printed, yes, right.
Okay, and I thought this looks like styrofoam. You know what I mean? Like
yeah,
a like
yeah,
a.
like a phone.
May I?
structure.
May I? Okay.
Yeah, you for sure.
Wow.
And it's also a multi-component part because here is a polypropylene as a hard material. So really to get your feet supported.
So then the flexible material, is it a TPU?
A TPES.
Okay. So thermal poly. What's the
Elastomer for
elastomer?
styrol. Yeah.
Okay.
So it had adhesion to polypropylene.
I see. Oh, and that's why you can do the part here with the polypropylene.
Right. And it's also the standard material is 46 Shore 8, and also
46.
46 Shore 8. Yeah. Right.
Oh, this is
And biocompatible. So you have certificate.
certified biocompatible. So stuff made. So any model made with this material is certified to be able to touch human skin.
It has the possibility to. So because the material has the certified, but honestly, if you go into a body part, you have to test it for sure. The customer.
Oh, absolutely.
But
Absolutely.
it has the possibility for the usage.
But this usage here, this is an insole for a shoe, and it seems like this is a perfect example of what additive is great at, is being able to make something custom and bespoke for its user. And you've actually showcased this here, and especially being able to use two materials. So then, is the machine that made this, is it the same machine that made this?
It was the same machine for the fan.
For this, okay.
Yeah.
But
and it's also impressive because the print time here compared to the fan was less than 3 hours.
Less than 3 hours.
Yeah. For it is size 42. So fit for my shoe.
Yeah. Well, just listen. A lot of times on the consumer side, when we talk about printing anything that's flexible at a good quality, you really have to slow the process down just so that it lays down properly.
Depending on our booth, we have different types of insoles, so different stages of resolution to get a feeling. So we have parts coming from 10 hours down to almost 3 hours.
And the integrated polypropylene part, was that printed at the same time?
Not at the same time on the same machine, but for example, you print first the PP and then the TPES.
Okay. So this part was printed fully?
Not fully in one layer, for example.
Okay.
You print first material 1, then material 2, and the support material. Was also here a water-soluble support material.
Is it different? So the machine that made this, because I'm not familiar with the machine, is it different heads or is it through the same head?
3-head machine.
Oh, it's 3-headed.
Yeah.
Okay. Oh, okay. So I see. So it is printed at the same time, meaning it's all in one.
Yeah.
It's
all in one,
okay. Perfect. Because it looks really good. Like if you print it separately and glued that in, I was going to call you a wizard because it looks really, really good.
But it was printed.
And a soluble support material.
Yep. Also a water-soluble support material. It was made for the adhesion to PP.
Oh, really?
Yeah.
Oh, I guess.
So this 3 parts has 3 different support materials. Breakaway, I would say a standard material for amorphous type of materials, and then the Armor 12, it's called, for semi-crystallized PP.
Oh, I see. I like that. You know, when we in consumer side, when we talk about the easy support removal, we'll do PLA prints with PETG, and it because it works well enough, but then it just pops away.
Yeah.
And so, but when we get into the professional side, like support material designed specifically for a printable material, and I love that.
You don't want to see any connection points.
No, none.
That you can see here.
And so there was support here.
Yep.
It's perfect. It's absolutely perfect.
Thanks. Can you show it to Peter?
I am showing it to Peter. Oh, hey, Peter, you want to see this? It's perfect. Like, this looks like a product.
It is.
You know what I mean? When we talk about things that are additive, it's like you get these sort of parts that they look cool, they look finished, and they're obviously useful. But when you see something that you've seen before as a purchasable thing in a store, and you're like, no, but this was made additive. It's like, oh, it really kind of sparks the imagination. Oh, that's cool. It's all flibbity flobbity. Oh, I love it. And it's for you, right? So are you wearing one right now?
It fits, yes.
Yeah. You got some good kicks there. I guess it would fit. Yeah, it's okay. So we got the insole. We got this. We got this. There's two now.
Now we have some little hearts.
May I?
Yeah, for sure.
This feels weird.
It's a little bit like a foam, honestly.
It looks fluffy.
It is.
Like, but it is. Oh
And-
my gosh, it's printed.
And the same material as the insole, colored in the machine via master batch. So 3% master batch colored directly in the machine. And there's also a story behind that. It is a product. It's also a customer made breast implants out of that.
What?
Yeah, right. And the benefit here is you have a dramatic weight reducing for that part. So the women who has to wear this have a benefit in less weight. It also more or less a part of clothing and not an implant. So it's also a thing for their mind, for the mindset of the women.
Okay.
And the cool thing is you can wash it. There's 60C in your standard washing machine. And it's hydrophobe, so you can just put the water away. It's really,
What?
Yeah. It's a great.
Like, this
great
is blowing
idea.
my mind. This material is crazy. This is weird, but in a cool way. This is like, Peter, can you see that? Because if you look at it, it looks fuzzy, like fabric fuzzy.
Yeah.
You know, it looks like thread made this, and it wasn't these are printed. These are 3D printed. Oh man, you could make children's toys with these. Like, it has that same sort of feel to it. I'm so that is weird in the best way possible.
It's really, really cool part.
So then, what do you print at home?
Honestly, I bought one for my wife.
Oh, okay.
In red.
Oh, that's a nice gift. I want more things made like this. Like, this is when we talk about additive and being able to have something that's very tactile friendly. You know, you have squishy things, and you've got very rigid things, and you have, you know, things that have fibers in them, carbon fibers or glass fibers or whatever, and they have a very specific feel to them. This is unlike anything I've ever felt before that's been 3D printed.
And we have a lot of more stuff, so you are invited to our booth.
I will come to your booth because I would like to see all of this other stuff. Yeah? Oh, that's a really good question. Okay, so the machine that makes this, how big can it make?
The 750 can print in the X direction 330 millimeters, in the Y 230, and in the Z also 230 millimeters.
Okay, so a pretty decent build volume for what we're going for here. Over 300 by over 200 by over 200.
Yeah, right.
Okay. Oh, so you could make really big hearts.
Yeah, for sure. Or a lot of the small ones.
Or a lot of the small ones, sure.
Depending on what you want.
People are asking, can you squeeze it?
Can I squeeze it? Yes. Okay, well, here, you get one, I get
Yeah,
this
for
one.
sure.
Okay, Peter, let us know when you're on it. We're going to be squeezing hearts, 3D printed hearts. It's so crazy. 3, 2, oh, you squeezed. I already squeezed too.
that was too fast.
That's all right. That's all right. Look at, oh. It's fluffy like cotton.
All directions, so almost isotropic.
It is.
It is.
It is. And, you know, a lot of times when we're printing something that has, that's flexible, like this TPES here, it depending on the infill pattern, you get different feelings depending on the axis you're squeezing on, but this is isotropically squishy.
It is. It's really coming. We also did, here we have really, really large droplets. We normally work with droplets. So in our system, we have a piezo actuator, and we are closing our nozzles up to 400 times a second. So if you go really in detail, this is really made by droplet chains.
Wait a minute. So we're extruding things.
Yep.
And typically there is a bead of material that comes out of a nozzle orifice in order to build a part. But you're saying it's not a bead of material, it is a continuous droplet.
Right.
Like 400 times a second, you said.
Up to. Yes.
Okay, up to. But still, that's a lot.
Yeah.
And so why? I guess I don't. What benefit does that offer?
You get better densities of the parts. So imagine
really?
if you go in a corner, and we can really go in detail into the corner with the droplet deposition. And so you get in over the whole part, you get a better density of the part, and in fact, you can achieve better mechanical properties.
Have you been able to film it at high speed to see the droplets come out?
We did it in our lab with a high-speed camera.
Really?
Yeah.
Did it look kind of cool?
Yeah, for sure. Really.
I know we don't have a lot of time. I've got one more question for you. What is the coolest or most favorite thing you've printed in one of your machines? Like, it doesn't have to be a mechanical part. This is pretty cool and all, but I don't want to influence your decision. But if you think back to the things that you've made on your Arburg Additive machines, which one really stands out as that thing that you love?
There are so many parts I really, really love. But honestly, I think one of the best parts are these breast implants. And why? Because it's really helping people. And it is also a product which really gives women a new mindset. So it's a benefit for their life, and this is what I love.
That's a good choice, man. Well, here, I just want to thank you for coming on board here. Arburg Additive with massive parts. Thank you so much. I hope you have a good rest of Formnext, and we are going to stop by their booth because I want to see more squishy things.
Yeah, you're invited.
I appreciate that.
Thanks.
Arburg Additive, everybody. Here, I'll put your parts over here. I don't want to steal your, well, I kind of do want to steal the parts, but I won't. I promise.
Oh, wow.
How is there? Let's see. Does it absorb water like a sponge? That's actually a really interesting question. There are voids within it just from the printing process. I know there's an infill. I would imagine it could hold water, but I don't think it absorbs water. Right? A foam sponge takes on the water. This would hold it. I think that'd be the way it'd go. When we stop by their booth later, I'll be sure to ask them. Maybe bring a glass of water and see if I can't put one of those hearts in there. Paul Blue, you can wash it in the washer. That's right. That material can be washed in the washer. The standard washer that washes your clothes. That's amazing. That's absolutely amazing. 60C to wash. That's right. Yeah, 60C. 60C. So, yeah, just a warm wash will do it. Oh, that's cool. Oh, that's really, really cool. Hope you all are doing. Squish Squish could be used to clean the dishes. That's true. That's right. The implants being able to use for breast implants. That's wonderful. That an additive process is being able to help bring peace of mind to those who are in need of those. I love that he mentioned that. No thievery this day. That's right. I did not steal any parts.
Photocentric is up next.
Okay.
Hanifa.
And we have what?
Hanifa
Oh, Hanifa.
and Photocentric.
Okay. Here, let me give this back to you, Peter. So up next on our wonderful live show here from Formnext 2023 is Photocentric and Hanifa.
Hey, hello.
Hi there.
Hello.
Come on up.
Hi.
It's just a step up. Here we
Yes,
go.
Yes, yes.
Well, hi. Well,
Yes,
it's really
yes.
good to meet you.
Really nice
Hanifa,
meeting you.
is that the
I've
right
heard
way to
so
say
much
it?
about- It's Hanifa, but
Wait,
no
it's
one.
what?
It's Hanifa.
Hanifa.
Yes.
Hanifa.
Yeah,
Okay, I
it's
stand
Hanifa.
corrected. It is Hanifa.
Yes,
Hanifa.
just the first one. Some of
Oh, there
but
we
it's-
go. Well, Photocentric.
yes.
Tell me, and those out there, what is Photocentric?
So the company is more than 20 years old. However, we started with 3D printing about 9 years ago. We are the first company who made LCD-based 3D printer.
The first.
Yes.
Oh,
the first.
there
the
we
first,
go.
The first.
Lots of people out there know about LCD-based resin 3D printers, and you were the first.
We are the first.
There we go.
Yes.
We know where it all
We were-
started.
Yeah, we all started in the UK. We are UK based. And now our specialty is in industrial, larger scale, large format 3D printing and affordable.
How
what-
large format are we talking?
Good question. So we have actually at Formnext, we launched our it's the largest LCD 3D printer in the world, which is by 695, 385, and 1200 millimeter. If you look at that
Whoa.
leg stand there, is a full height
Oh,
of the print. Yeah.
okay. Okay. So that massive 3D printer that you just mentioned made a part that I'm looking at,
Yeah.
and you'll get to see it soon.
Yes. Yes. Yeah.
Wow. Okay. Well, okay. So that's for a little bit later. We gotta tease them a little bit.
Yes.
But what do we have in front of us here?
So, right, let's one by one. So the company, my company, we make the printer, the material. We are daylight 3D printing, not UV, which we can get that to that one later as well.
Wait, daylight.
Yeah.
So we don't have to worry about the sunlight coming into the room accidentally curing things.
No, actually, we should worry about that more.
Oh,
Yeah, because our the LED we use in our printer is 460 nanometer.
daylight meaning you print with daylight,
Yes.
not that you don't have to worry about daylight.
Yes.
I apologize.
No, it's okay. It's okay. And the beauty of printing with daylight is, the majority of the UV printers, they degrade their screen. Daylight doesn't happen. In your phone, in your laptop, you use visible light all along, and they don't get degraded by visible light. And also, it has a thicker penetration of light, and also it gives us more reliability in terms of large format printing.
Oh, okay. And so
Yeah.
typical consumer machines are 405 nanometer.
Yes.
So 460 is good is daylight, and that's
Yes.
good enough to be able to print.
Yeah.
Oh,
It's invisible spectrum. That's why we call it daylight. We
Okay.
came up with this name, with daylight.
I like
Yeah.
the name. No, I think it's very interesting because anytime that you want to make people more aware of what you're doing, you have to relate it to something that they already know.
Yeah.
And when we talk about, this prints with daylight. Oh, wait a minute. I know daylight. I know of this. I've experienced it. And you can print with this. And it's kind of a way in to be able to really tell people about what you do. And I love that.
Thank you very much. So I have, as I said, so we make the printers, the materials, and also we encourage ourselves and also our customers to print in larger scale. So
Okay.
this part is the part that we have a full platform of it there, which looks be that platform if we can. So one of our dear
Oh.
customers, Mary 3D,
Oh,
they have. Sorry,
There we go.
We just
there we go. I want to make sure Peter can see this.
So there is 748 parts on this platform.
Well, I remember
Yes.
he talked to me, and it was 1,000,000 parts, I think, right?
Yes.
Wow.
The story behind this is his customer, they struggled to supply injection molding with the recent climate changes in the world.
Understandable.
So he has 26 magnets. So he's scaled up his production line in 2 weeks with a liquid crystal magnet, which is our printer. And this is the resin we have developed with BASF EPD 1006. And and the beauty of it, not only he could make it cost competitive, but also he could, because of the additive manufacturing design, he could merge 2 parts in 1 part and continuously even improve this. So he made it lighter and lighter, but stronger and stronger.
Oh, that's perfect. That's what additive does.
Yeah.
You're trying to solve a problem, and you can reduce weight, make it custom. May I see that?
Of course,
So 1,000,000 of these.
a million of these.
Can you see
yes.
that, Peter? Look at that, 1,000,000 of those. 1,000,000. And this is additive actually taking the place of what would have been injection molded.
Yes.
Oh, that's a fun story to
Yes,
tell right
that's the
there.
bonus to it.
Because most of the times people, when they know, they go, additive is great once you get to a certain volume, but after that you have to go injection molding. Do you now?
Do you know? Exactly. And the beauty of printing with LCD is that it doesn't matter if you put one or you fill the whole platform. It just takes the
Same amount of time. Yeah. So being able to print this then took no time because it's not really that tall in Z.
It's not that tall. It took about less than 4 hours at 100 micron layer thickness.
How many here? 748.
748.
748 of these
Yes.
in less than 4 hours.
Yes.
And what are these used for?
Excellent question. So when we go to the tool shops and they have a silicone tube and a nozzle. So actually this was just to pack the silicone tube and the nozzle for the silicone glue
Oh, okay.
and gun. Yeah.
Oh,
It's just a
that's
packaging.
great.
We
It's
call
packaging.
them holders. Yeah.
But I mean, injection molding is used for packaging holders all the time, right?
Yeah.
So to be able to use additive in order to create the thing that's needed, probably less expensive than starting up an injection molding process.
Absolutely.
And being able to get it so quick, that's
Absolutely.
really a testament to how far additive has come.
Absolutely. And you mentioned a good point. At the end, because of everything we do, this part was the cost was cost competitive to injection molding part as well. You know, injection molding can go really, really low in cost.
It can after you get the tool made,
exactly,
right?
after the tool.
Yeah,
yes,
after the tool is
yes.
made. But you have to take the tool production into the cost of everything because you have to make a custom one. And if for some reason there has to be a change, you have to remake the tool at a very significant cost. Whereas additive, you can. Oh, this is a wonderful story for additive because we're talking about something that should have been injection molded, but additive was able to make the part, was able to customize the part, and was able to compete at price with injection molding.
Yeah, and it has a happy customer as well. They didn't need to hold their manufacturing because they didn't have the parts.
Oh, that's cool. That's really cool. So what is this
I have
here?
another cool things to show you.
Oh, well, here, let me. Can you take this, David?
Yeah, absolutely.
Thank
is
you
this
very
the build plate that it
That
comes
is the
on?
build
This
plate.
is the
Yes,
actual-
yes.
Yes, it is.
Except that thingy.
Except the handle, that's for holding.
Yeah, that's for holding.
So
Yes.
kind of-
That's the handle of
thank you.
holding.
Thank you.
Yeah.
Thank you.
May I touch this?
Of course.
Okay.
Of course.
So this is, I would have,
So
right after this is when we'll do that part.
I know you have so much experience with resin 3D printing.
I do a bit here,
Yeah.
here and there, yeah.
And you know the parts that they have a high aspect ratio means that they're thin but they're quite long.
Yes.
They come out warpy, right?
Yes,
Yeah.
yes. There's
they come
been a
out
number of
warpy.
times where I've got, yeah.
Yeah. So we have a new solution for our customers, which we call it Weave.
Call it
And
what?
Weave.
Weave.
Like, yeah.
Okay.
Like Weave. And this is actually the first prototype of that. This is, if you come to our stand, you see the final prototype. So by design optimization, a bit of simulation, and a bit of latticing, and also the printer as well as the material, you can actually print your stuff flat with high aspect ratio.
Wow. So flat on the build plate and it holds.
No, it was on support. This is the support mount,
Oh.
so it was like that.
Oh.
Yeah.
Okay, that's crazy.
Yeah, I know.
I was like, oh, okay, I understand that, but I didn't. I guess I didn't understand it. Now I understand it, and that's amazing. Yeah, you're printing this tall,
Yes.
like they're. I know people can do it, but they have well-adjusted machines. They know how their machine works exactly. They can do it once or twice easily. But when we talk about the production of something, that's a little bit different. But because of your material and your machine, you're able to fine-tune everything.
Yes, and also simulation, and also a bit of
The des-
weave,
the
which is
design-
the latticing. Which is,
Yeah, the weave
this
is
the
really.
this is actually, interestingly, this is for the small format printers that we have in our product range. It's not launched yet, but we printed the panel
Mhm.
on LC Magna, which goes from LC Nano, which is the smaller format printer.
Oh wow.
Yeah.
That's geez.
So instead of ordering panel outside, we make them in house. Yeah. And flat. That's the secret. Yeah.
That's really cool.
Yeah.
But I mean, we need to bring this other piece up.
Yes,
Like
we
I
should,
could talk more
we
about
should,
this, but
we
I don't
should.
want to.
We should.
You got that, David?
Oh yeah. Should we
Yes.
should we move the table? Or you want to put it on the table?
Let's put it on the table for now.
And there is a logo there as well. It's Photocentric logo. If you,
Oh yes, yes.
So the story behind this part is
Actually, I think I'm gonna move the table.
Yeah, okay, wait.
More of it. Can you what? Oh wait, hold on, wait, Joel. Actually, hold on.
Okay.
We're gonna zoom out. There we go. All right, yeah, we're wide.
Oh, we're okay.
We got it all.
Hi everybody. Now from the wide. Look at that. So this is like a lectern.
yes, well done. Yes. So we had an event coming up. We didn't have a lectern, and it was like we had a 2-3 days deadline. So we printed one. We designed it in 3 hours, and then we printed in 60 hours. And there you go.
It's funny because when I think, oh, you know what, I have something coming up. I want to print it. We're talking about a 1 hour part, a 2 hour part, something like that. You're like, we need a lectern, so we're just going to print the lectern.
Yes. Design and we printed, and then obviously it didn't come out in colors. We painted it as well.
Oh, sure.
Yes.
Yeah. That's not cheating. That's just making your part.
Yeah.
But this is cool. So and this is now you have a lectern showcasing your technology, and you can bring it to these places, and that's wonderful.
And the layer thickness 250 micron as well. Again, with daylight, we can easily do thick layer thickness.
250 micron, you
Yes.
said. 250 micron. Okay, okay. That's impressive.
Thank you.
Like, you must love this. Like, just the size and scale of it is massive.
Yeah, I agree. If you come stop by our stand, we have a tall Neptune as well, which is more than
really?
2 meters. It hasn't been printed in one piece. It has been printed in 3 pieces. You should stop by. There are so
I might
many
have
cool,
to do that.
Cool parts.
I might have to give a class at the lectern here.
You should. We should. We can print you one.
Really?
Yeah.
Did you hear that, David? They can print me a lectern. Can you make it blue?
We will paint it.
Okay, I appreciate that. Yeah. Yeah.
Make it the Joel bot holding the lecture.
I love the design of this. So then you said it took you a few hours to design it, right?
2 hours, yeah.
Okay. Now, is this pattern, is this an automatic thing you hit a button in, or do you have designers that specialize in this pattern?
They have a specialized nice button.
Okay.
Yeah.
Well, this is fun. Okay. We have a little bit more time.
Okay.
And I want to ask you, because I ask everybody here,
Of course.
you work for a very professional industrial company here making incredible stuff. Do you 3D print at home?
I did used to have an Ultimaker,
Okay.
and also I used to have our first ever printer, which we call it an LC10, which is a 10-inch screen. So I used to have those 2 printers at home.
Okay. Oh, so you've done standard FFF printing with your Ultimaker,
Yeah.
and you've done resin printing all at home.
Yeah.
Hey, high five for that. Jeez. Most of the time when I ask people about printing at home, it's famous to me at this show that a lot of the people at the booths don't actually print at home because they're at industrial companies and they don't have these industrial machines at home. But you have an Ultimaker, or had an Ultimaker
I
at
had an
least,
Ultimaker, yeah.
and you had your company's resin printer
Yes,
at
yes,
home.
yeah, yeah.
Oh, you're cool.
Thank you.
That's pretty cool, everybody.
Thank you. Most of us has the smaller printer at home, to be fair.
That makes sense.
I'm going to strike the lecture to let you guys wrap up, and I'll get our shot
Sure.
back.
Okay, careful with that.
I got it. Peter, would you get our shot back? I got it, Joel.
Okay.
Thanks.
David's got the
Thank you
lectern.
so much. Thank you.
Well, I know we have a lot of other people coming up. We don't have a lot of time, but one of the questions that I wanted to ask you is, in your line of work, and I've asked other people, how does experience at home translate to people who do work for your company? So, like, is experience in resin printing at home applicable to what people do at your company?
You know what is? I think for me, what is applicable is that the kind of difficulties that the customer going through, when you go through them yourself, you actually help to find a solution for your customers. Like, for example, you know, we always, when we have LC Magna, when we launched LC Magna, we were offering our customers to clean it with resin cleaner and then rinse it and then dry it. But we didn't have one unit to do all of them in one.
Okay.
But when we launched Titan, because we all went through the difficulties ourselves, like, oh my God, this is so messy, it takes a lot of room. Now we have designed a cleaning unit that it does all of those 3 jobs in one job. So I feel like for me, to enhance the user experience is very important for us to use the printer. Not even at home, we use the industrial one at work as well to just go through the customer user experience and just make it better. Think about customers.
I am 100,000%. I agree with you on that, and I'm so glad that you mentioned that.
Thank you.
This has been Photocentric with
Yes.
amazing things. Thank you so very much.
Thank you for having me.
Oh, thanks for coming on, and we'll
Thank
have to
you.
stop by your booth. Have a good rest of
Thank
Formnext.
you very much.
Well,
The
I guess
same to you.
we'll see you at the booth, and I'll give you a lesson from the
Yes,
from
please do.
the lectern.
Please do. Thank you so much. Thank you.
See you later.
See you later.
Oh yeah, don't
I'm
forget your
gonna
parts.
Take all of my
Take all the
little
wonderful
things.
parts.
Thank you. Thank you very much. Thank you.
How cool was that? Oh, thank you, Peter. Uh-oh. I fixed my mic. Thanks. Look at that. Oh, it would be cooler if a frosted tube down the center with LED tape inside. I would have to agree with you. That seems like a really interesting idea. Thankfully, that's not the last lectern they're going to make, my guess. Was Photocentric a supplier of dental 3D printers back in the day? When we stopped by the booth? I will find out. Oh, wait a minute. Does Photocentric, were you originally suppliers of dental machines? Yes. What's that? And they still are. There we go. I didn't even have to go to the booth to find out. They do have, yeah, there we go. There we go. 3D Print SOS, this is super cool. Yeah, I'm really glad you're enjoying our time here from Formnext 2023. I need to get a sip of water here because it's difficult to just keep talking. Listen, you guys out there, everybody watching this stream, take a moment, find something to drink. Make sure it's something you enjoy. Take a sip. That'd be good. Sam, come here real quick, like super quick. There it is. This is Sam Prentice, everybody. Sam Prentice. The lights are really hot, I know.
It's really warm up here. You're looking good under these lights, though. I've got to say, it's insane.
You look pretty good too.
Thanks, man.
Here, wait. You want to give me put that on and do the famous line.
I'm the oh my god, guys! It's the new bamboo.
There it is. Yes.
So I've been called the Temu Joel Telling today.
Oh, the Temu. Oh, not the Wish Joel Telling, but now the Temu.
It's Temu now.
Okay.
Yeah. So that's interesting. But listen, you're busy. So, dude.
Good to see you, man.
Love you, man.
I'll see you later. Love you right back. That was Sam Prentice, everybody. Sam Prentice. I think our next guest is getting mic'd up right now. Our next guest? Ready? I think we are. Peter, this is for you. Our next guest, I've been learning Czech just so I could talk more to him. This is Joseph Prusa, everybody.
Ahoj.
Ahoy.
Co ses naučil česky?
I don't know what you said. I'm not that far in Duolingo.
I just asked you what have you learned in Czech.
I learned merkev, carrots.
Oh. Okay.
Yeah, you know when
that's a start.
You know, I do my Duolingo at night right before I go to bed, and sometimes I do a couple lessons, and I'm like, yeah, I can't wait to talk to Joe, and then I forget it all.
That's fine.
That's all right, dude. How are you? It's so good to see you. Happy Formnext.
Yes, I'm fine. I'm finally feeling better.
Good.
But everyone around me was sick.
Oh no.
And I just recovered like Friday, Saturday. So I'm good, but still a little bit tired.
Okay, that's fair. That's fair. Well, don't worry about it. What's that? Oh, well, first, yes, let's bring up parts. And while parts are being brought up, let's just mention that you dropped a surprise on us this morning with a brand new machine.
Well,
and Prusa Pro.
Two machines.
Two machines.
I told you I will be able to surprise you. You thought you know everything.
I rarely do I ever think I know everything. I know way better than that. Okay, we've got some.
We have plenty of stuff.
We do have plenty of stuff. Well,
so
I'm going to let you drive at this point. What's first?
So I will start with the simpler things.
Okay.
So we actually have new RPLAs.
Are being recycled.
Yes.
Oh, and it's sustainability as a theme of Formnext this year. Yeah.
Yes. And also there's other waste added to it. So
other waste, other non-specific waste.
Yes. So I think this is coffee.
Oh, okay. Oh, that sort of way. Okay. Oh.
And this is with waste from manufacturing wine. And this one is with waste from corn.
Oh, and so the waste product is what's contributing to the color?
Yeah, to the color, but also it allows you to use less of the plastic.
Oh, I see what you're saying.
Sort of a filler.
How much? What is the percentage of like corn or wine byproduct or coffee to material?
Oh, it is specific for each of these recipes.
Okay.
You can get that. You can get that on our website.
Oh, that's right. You've got that listed there. Well, but I was like, it's not like 50-50, obviously.
Yes, it depends. It depends, but I don't think they are this high.
Okay.
And it mostly adds that little bit of organic feel compared to just plain plastic.
Well, when you look at something like this, I think it has to do, for me, with the color. I don't know so much as the texture, but the color looks organic in nature. It doesn't look like a manufactured color. It looks like, you know, nature colored it. And that's, I think, because of the corn or the wine byproduct. Like the deep color here is fantastic. And coffee, I love coffee. Does it taste like coffee?
Well, I hope it's coffee. But yeah.
And then the R in the RPLA is, so the PLA material, okay, I think it's coffee.
Yeah.
It doesn't smell like plastic.
No.
So then for the R for PLA, you're using organic materials, but you're also, the PLA itself, is that recycled from the manufacturing process?
Oh, it is recycled PLA plus the
Oh, I know, but the recycled PLA is from the Prusament lines, or are you purchasing it bulk?
Either or from someone who is recycling it.
Okay.
Because we do not have our fail rate at the factory is not that high, so we don't have that much to recycle.
It almost made me fall off the stage here. That's really cool to hear, that you have to acquire material because your failure rate is so low.
Yeah.
Like, that's cool flex, bro, sort of stuff, right? Like, you just nonchalantly were like, we don't fail enough to make recycled material. Okay, that's cool. That's cool.
Sweet.
But I like it. Printability, how is it?
As good or better. We do not release materials which are difficult to print.
I understand.
Well, I would not expect any difficulties printing.
Okay, that's fair. Is this available now?
Yes.
Oh,
yes, really? With a short lead time, but yeah, you can buy it on prusa3d.com.
If this is successful, are you looking at other organic materials to add to your recycled line?
Yes.
Oh, yes. Okay. When I come over to Prague sometime, can I help make some?
Well, if you go through
Not there was like
if you go through the safety training, you
okay.
know, how is it named in US?
Oh, we got OSHA, right?
OSHA.
Yeah.
Yeah.
Okay. We'll put it through a check-based OSHA. Okay. Cool. Okay, so that's the recycled PLA.
Okay.
It looks really good.
And now, next one, I would do this because this is, you've been printing on the Excel.
Yes, I recognize this purge tower right here.
So I wanted to bring nice multi-material showcase.
I saw the tire, the TYRE tire.
Yes, but this is a case for mics, and these are printed from TPU.
Wait a minute! Oh my gosh! Look at that!
And the base is normal PLA, and you have like these shock absorbers.
Yeah.
So it is a model from our colleague Dominic, and you know you have the other part, and you can safely travel or ship your microphones. And this is
really cool.
This is using a very large part of the Excel build plate, and as a little show off, so this is the size of the priming tower.
Yeah. So you call it a priming tower because it is priming the nozzle.
Yeah, this is just, it's just for priming, because as the extruders are sitting, idling, the plastic is decomposing a little bit, so the volume is changing. So when you can technically go and start printing the line, but very first few millimeters
I see
would not be perfect. So
well,
that
you saw Filament Frenzy. He's doing a no purge tower print right now.
Yes, I saw him.
He's a wizard.
I saw him, and all of these things are entirely possible. Also like with the stringing, if you really properly dry out the filaments, you can drastically reduce the amount to purge and wipe.
So really quick though, before you move on to something else, I really love the idea of multi-material, and I love the idea of Excel because it is a tool changer, and so you don't have to send TPU through the same nozzle as PLA, through the same nozzle as ABS. But what I'm wondering is, and I guess this solves the equation right here, how does multi-material work for a prime tower? And in the case of TPU and PLA, it looks like it works just fine.
Yes. So the materials, they do attach to themselves, slightly, not for the mechanical purposes, but also in the tower you can see that I would say they are held together mechanically. As it is not just lines, a line next to line next to line, as they are doing the
Yeah.
zigzag. It basically interlocks everything together.
Well, it looks like you've got PLA on the outside, and then you've got the
Yeah, yeah.
flexible on the inside, and so it's almost it's almost like it's kind of housing the material, right?
And you can see on here the wipe towers or priming towers, they are so small that we had to invent a stabilizing feature. Because
I wondered what that was, and it's to stabilize it.
Because if it would be this long, for example, then it would be so easy to rip it off the bed.
Yeah.
So we have the cones, and they basically grow. It's just single line, providing it the base, so it can stay.
I love. Well, I printed pretty tall in my XL, and I've got it in a very wide base on my prime tower, and it's perfect though, because the prime tower, this wide base part, isn't full. It's just a single line.
We can maybe show it.
Well, I mean, it's got the lower layer.
Yeah, you can see. I just punched in the first layer.
Here, I'll hold it for Peter here. Yeah. Peter, can you see that? Oh no, it's cracked open. But Joe just pushed in the floor layer here, so we could see that this outer stabilizing part is not full of material. It's just a single extrusion to kind of keep it stable. And I was telling him that I've gotten some pretty wide purge towers, prime towers in my day, because I've printed a lot with my XL.
Yeah.
But I love that. It's really cool being able to do that.
Yes.
It's really cool being able to do that.
And yeah, we've been talking about the true multi-material support. What I see and what we actually do in-house, and I see it now with people in the community. You can use PLA and PETG as support because they do not bind together all that well.
Right.
So you get basically the surface level quality on the supported surfaces of water soluble supports, for example.
Well, yeah. So if you use PETG as the interface layer between PLA supports and PLA part, it just pops right off, and it's nothing. Oh yeah, I've done that. I actually did that long ago on another machine that I won't mention because this is your time. But I've done that long ago, and it was fascinating how well it worked, and to be able to do it without the manualness of it is just wonderful.
Yes. Shall I talk to the colleague to upload this to printables?
Sure. Well, I think it would be really interesting if, this is more of a demonstration, and people are going to have other things. Like you could have GoPro pockets or microphone pockets or anything to be able to pack them. Like so to come to this show, I had a backpack just stuffed full of equipment because I had to get it on an airplane. And so to be able to, I have a roller bag that I keep my clothes in, and sometimes I have to throw equipment in with my socks and underwear. And I've said to my wife many times, I wish I could 3D print something to hold my equipment in my bag to keep it sturdy rather than having it being supported by my socks and t-shirts. An organizer. And this is what this is with the shock absorption, because no one is kind to their bags when they're traveling. And so this is almost essential. So this is inspiring to me, and I love seeing this.
Sweet. And now to the star of the show, one of the two new printers. I brought this in here, and this is printed from Ultem.
Ultem 9085, right?
I think 1010.
Oh, 1010. Okay,
yeah.
Okay.
And it is demonstrating that we can now print Ultem because our new Prusa Pro HD90 has a heat chamber.
How hot does it go?
guess HD90.
Oh, 90C? Is that where we're
Yeah,
okay, wow, look at that.
to the
I'm smart.
to the 90 degrees Celsius.
Okay.
And hot end up to 500.
Wow. Okay.
So we can print this. You cannot print full volume. We say that it's small to medium.
Okay.
But then you have all other high temperature materials, and you can print basically all of them.
Well, you've got PEEK and PEC. So
Yeah.
Ultim, PPSU,
polycarbonate,
polycarbs.
nylons.
Well,
everything.
polycarbs and nylons were approachable with your Mark IV, Mark III.
Yes,
but very tiny.
But for example, the PC blend, we specially blended with our herbs and spices, so it can be.
What are you, Kentucky Fried Chicken?
It can be printable on the Mark IV.
Okay.
And has fantastic results with heated chamber. It is on another level.
Really?
Yes.
Okay. So the HT90 really excels with that heated chamber to be able to print the PC blend.
But also, it excels with PLA too.
Oh, well, you're not heating the chamber at that point.
No. But so for example, for printing PLA, there is a flap, and we get the cooling air from the outside, ambient.
Oh, okay.
Not from the inside. So you can print full speed PLA without like having to open the door or something.
Oh, so you're still enclosed
Yes.
because you're bringing in ambient to
Yes.
cool. Oh,
Yeah.
okay, that's amazing. Here, I need to touch this part. This is cool.
And I really
Wow. No supports.
no.
No,
I
But
really,
I mean, if you look at that, that's a really good hole. Like that's a proper hole printed in Z. Like that's good. That's really good.
well, it shouldn't be possible or something.
Well, no, you're just printing with a higher temp material, and so the heat, and the cooling is a lot different, and just.
Oh.
I mean, of course, you've solved this problem, but I mean, this
But-
part is nice.
Yes.
Really, really nice.
And so I really think that I'm jokingly, but it's true. It is the only printer an engineer needs, because
I saw that tagline.
because you can really quickly prototype from cheap PLA. We have the accelerations of 20,000 millimeters squared, but can go higher. This is just the base.
Well, because it's a Delta platform,
Yeah.
so it's light head and just moves really quick.
And you can go through 1 kilo of PETG in 8 hours. I think. And-
Really?
Yeah. And when you finish the prototyping, you can run it from the expensive, I don't know, nylon CF, and have the final part. Then for some specialty, high temp or parts which need good extreme chemical resistance, you can print from Ultim. But also the extruder is very optimized for flex, so you can print gaskets or basically you can do anything on that printer. So if you are setting up an engineer's lab, you can just get 2-3 of these, and you are set up.
That's cool. Well, actually, this really makes me think, because we call it dog fooding your own stuff. At Microsoft, it was a term where you use the software you make.
Mhm.
So you use the printers you make to print things at your factory.
Yeah.
Then with the HT90, is that going to provide printed parts for things that you
Yeah.
need? Like
Yeah.
PEEK and Ultim, do you need those parts on things?
Yes, definitely. For example, on our testers, hot end testers, where we are testing the heaters up to the temp, we can use this.
Oh, yeah.
And yes, there's so many more things. How much more time do we have?
Oh, we got like 3 minutes, Joe.
Oh.
2 minutes. Okay.
Okay, so that's one printer.
Okay.
And it is finalized, and we are now setting the production up.
Okay.
So very early production starts very early next year.
Okay.
And then we have Prusa Pro SLX.
The SLX. I saw that.
And big and very good MSLA printer.
You have it here at the booth at
Yes,
Formnext.
we do.
Ooh.
I hope you'll get some shots of it.
I will, absolutely.
And heated chamber, automatic calibration. There's a lot of little things which will be better if I show you when you come over.
I'll come over. Yeah, I'll come find you.
And that one is finished, but we are still at the stage that we can get feedback from potential customers and make it even better.
That makes sense.
And that so the time frame is a little bit later.
Okay, I think that's fair. You know, it was 2 years ago Formnext that a 5-headed tool changer was announced.
Yes.
And I remember I was pre-order number 3.
Oh well, there is a lot of XLs in the wild.
Yeah, there is, and a lot of people are thankful that they got them. I'm seeing a lot of feedback in the Facebook groups and on Twitter, people posting these amazing prints they're making with it.
And there's so we are now finalizing the firmware 5.1, and after that there will be something super special for the XL in the 5.2. I think.
Okay. Any hints?
I sneak peek it to you, and that will be it. So you can just say how awesome it is.
If it's what I'm thinking it is, that's really awesome. That's okay. I'm not gonna say another thing. Joe, this has been fantastic. I'm really thankful to
see you.
have you on the show, and congratulations on all your success, man.
Thank you very much.
That was Joe Prusa, everybody. Prusa 3D. Over there, that camera. Wave at that one. Good job.
Thank you.
Okay.
Wasn't that bad?
Wow. Well, that was fun. Prusa Pro, the SLX, a 12K MSLA printer. That's going to be at the booth. Finalizing firmware updates for the XL, the HT90 being able to print Peak and Ultim and PPSU and nylons and. Oh, okay. Table's going away. Sorry, everybody. Look at me. I got my drink and I got my iPad. Here we go. Actually, Pooch, come here. You want to hold the iPad for me? Thank you. Does Joe ever not have something new coming?
No.
Where are my grapes? Where are my grapes? Morning all from Practical Printing. Oh, that's right. It's all. So it's an all-in-one. Yeah, the HT90. Oh, thank you, sir. Oh, LDO Motors in the chat. Oh my goodness. We have, okay. Well, I'll tell you what.
Out of here.
Thank you, Pooch. Thank you, Joe, for the help. Peter, I'm going to give that to you.
All right. You guys want to just take it off, or you want to take it all as well? All right, Peacock, the carpet has a little bit of lift.
I am going to get out of the way for this one. Okay, everybody, we are. You guys make it look easy. Yes, my mic is live. I'm just taking this all in. This is how we set up things here, you know. Well, this is fun. Of course you got lights in this thing. We're starting to rave here. It is? Okay.
Can we turn off lights? Can we turn off
lights? It's a pretty regular flash.
We can. We just need to do that clip and unplug them.
They have to be turned off.
Okay. Have to be turned off.
Just in case. We don't want to. Yeah. But people have been able to see it, and then we'll turn them off, and then it'll be all good. Oh, here we go. See, this is why we do it live, everybody. So right now what's happening, a screwdriver is being used to loosen a clamp, and then they pull out the clamp, and there's a little, oh, there you go. There we go. Look at that. All done. Hey, good job.
Can you put the smoke on?
Yeah, you can put the smoke on. Okay.
Hide it.
Maybe. Possibly. We'll see what happens.
I'm just hoping we haven't killed it by undoing the lights.
Oh.
But I don't know.
So there is a smoke machine in here,
Yeah.
and it may have been killed by unplugging the lights.
Oh, no.
Oh.
Put it back on then.
Well, here, let's plug the lights back. Oh, you tightened that up proper, didn't you?
Yeah.
We'll fix it.
Yeah. Just wait a second.
That's all right.
I guess let's turn it back on and see what happens. Okay, we're gonna put those lights back on. This is what happens when you do it live, you know? Sometimes you just have to take a moment.
Yeah.
There you go.
Let's see.
Oh, it's working.
It's working.
Oh, there you go, it's working.
It's working.
It's on fire.
It needed time. The dragon needed time.
I guess so.
Right. And I'm out of here.
Just took a second.
So now is it
Travis, all yours.
okay?
All right.
Hi there. Well, let's see.
Hi.
Can
Is this a good place for me to stand? Okay.
okay, I'm on. I can see me.
She's a little bit out of focus.
Okay.
Oh no!
Oh no.
There's a printer fire. No, the smoke.
printer's
No,
on
there's.
fire
I'm,
again.
the smoke just popped out, and so I'm like, oh no!
All right, you're locked here. Let me see.
Yeah.
All right, there you go.
Okay.
And I'm right here.
A little soft, Joe's a little bright. That'll be fine.
I can step back.
It's better. She's soft. She's too close. Why don't you guys stand next to each other?
Yeah. Should I
That work?
Where?
do that?
Oh, you're fine right now. We got
Okay,
you. We got you.
perfect.
All right, now we're all good.
Oh, all right.
Okay.
What was your name again? Remind me.
I'm Shravya.
Shravya.
Yeah.
Shravya, and this is Shravya from BOFA.
BOFA.
Yeah.
Not Bank of America. We get that all the time.
Well, people actually out there are probably going to be familiar with BOFA because I've showcased BOFA filters before on the show, and they've worked really well. In fact, I worked with Dave at Printed Solid, and I showcased how having the BOFA filter in an enclosure really eliminated the ABS smell.
Yeah.
Because the ABS was giving me a headache, and so then I showcased how that filter can filter out the ABS particles and make it better. So now, though, you have a much more visual demonstration. Can you talk about this?
Yeah. So when you're printing materials, sometimes you have a smell, sometimes you don't. But there's two different types of emissions that are being given off. You have your particle emissions, and you have your gases, VOCs, odors. You know, people call it by different things depending on what they're most sensitive to. But because you can't see it, we've put a smoke machine in there to simulate the emissions that are being given off. Because if you can't see anything being filtered, you're like, what is this unit even doing?
Yeah. Oh, absolutely.
So we have a smoke machine that's routinely running on and off while the extraction then turns on, filters out the air. As you can see, it's clearing it up.
Oh, I see.
Yeah, and another good indicator of this is you can actually see on the hose, there's a lot of glycerin that's been built up. And then the hose in the back, it's actually quite clear and empty in it.
Oh,
Yeah.
okay. Oh, so this is condensation from the smoke particles coming through.
Particles, and
Oh,
it passes
cool.
through the
Looks like you
filter.
guys- I'm gonna check your
Sorry.
audio. I think I'm going to switch the spot where your mic is because you're talking the other way. This might be a little better.
There we go. We got to make sure everybody can hear you.
Yeah.
Okay, great. Keep going.
All right, and then at the back, it's in a recirculating loop, so it's constantly printing. It's constantly filtering while you're printing.
I see. I see. Well,
So-
it's got a bunch of layers here. The one I used didn't have this nice cutout here. So this is actually showcasing the various layers of filtration, right?
Correct. So we have both a HEPA filter and a carbon filter. The HEPA is made out of like a borosilicate material. It's there to capture all of your nanoparticles that are being given off, and the carbon is there to capture the VOCs. So it's really cool. It's really neat. You can set your airflows depending on what your needs are. We recommend, higher airflows if you have a bigger volume.
That makes sense.
Yeah.
You want the most filtration, and or do that, you have to move the most amount of air.
Exactly.
Yeah.
But you also have to be careful because you don't want it to run too fast, because then you don't want to warp your print or dry it up too quickly.
Oh, well, That's true. So if we're
Yeah.
talking about PLA, usually that's not too much of a concern,
Yeah.
right? Because it looks like you're actually recirculating it back into the system.
Exactly.
So how much of a temperature differential is there from taking this here and putting it back in? Do you know?
Yeah, so the way the carbon works is it actually works the best at 40 degrees Celsius and under. When you go up to higher temperatures, carbon does the opposite of what you want it to do. Instead of absorbing all of those VOCs, it spits them out. So we have a unit coming out soon that's specifically designed for your higher temperature printers.
Okay.
Yeah, where you separate the HEPA filter with the carbon filter. And in that, we see a temperature decrease from 100 degrees Celsius, if that's the chamber temperature you're operating at, all the way down to around 30, because we're also mixing in ambient air to cool it down rapidly before we pass it through the filter.
I see. Oh, okay.
Yeah.
That makes a lot of sense to bring it down to the proper temperature in order for the activated carbon to work. Okay.
Exactly. But if you're focused on, maintaining the heat and keeping it in a recirculating loop and passing it solely through the HEPA filter, it loses about 10 degrees Celsius.
Okay. So this is the 3D Print Pro 3?
This is the 3D Print Pro 3, yeah.
3D Print Pro 3. Okay. And I know that there was a couple different models when I tested this. And this looks to be the medium model, is that right?
That's correct.
Okay, and what sort of enclosure size is this meant for? Or is there a certain amount of air that it's predicted to move? Or how would someone out there who's interested in filtration pick the right thing?
So how I would recommend it is we have the 3D Print Pro 2 with a stay put arm. That's for your open frame printers. When you're printing at home, you don't have an enclosure. It has an at source capture, so that's better. Just if you don't have an enclosure, it's hard to build one. We also don't sell the enclosures, but we've gotten a lot of inquiries, so maybe we might have to bring it to the market.
Yeah, you never know. And so that one is where this end actually has that articulated arm that you can put right by the machine,
and then there's a cone nozzle that allows you to capture it more effectively.
I actually have that and use that to this day.
Okay.
Can I tell you a funny story real quick?
Yeah, of course.
So I have this. I had it at home when I was printing some certain materials in a very enclosed room.
Yeah.
And I didn't want to risk the off-gassing of whatever.
Yeah.
My wife was cooking some bacon downstairs on a pan, and the vent fan went out, and so it started getting into the kitchen, and it was getting a little smoky.
No.
I brought this downstairs and put it just over the pan, and it cleared it up right away.
Oh my God.
And so we were able to
that's
continue cooking without filling the kitchen.
Oh, I love that.
And so it's a visual demonstration like this, and slightly tastier. But that's become really useful. That cone, to be able to place it, was really useful, not just because of my bacon situation, but because being able to put it next to a printer with a moving tool head, just to kind of capture anything coming off in a small room, it was really useful.
Exactly. But if you have an enclosed printer like this, then you can keep the 3D Print Pro 3. And since it's in a recirculating loop, it can actually, the size that you attach it to can vary a lot depending on how long you keep it running after the print is over.
Oh, I see. Oh, yeah, you can't just open the doors right away.
Exactly, because you're going to get a couple of different air exchanges. We recommend at least 5. If you have a much larger build volume, then you're going to want to set it up to speed of 6. That's around 270 meters cubed an hour.
Okay. Well, and I would imagine something like this with a recirculating loop, this size, we're looking at like a Ray's 3D machine, maybe like a Cheedy machine, a Voron.
Yeah.
I would imagine there's custom mounts and gaskets to be able to put it in recirculation mode.
Yeah.
Stuff like that. Yeah, that's really cool.
3D printers aren't designed with extraction. We have on our website, connectors that you can print on your own.
Okay.
So depending on the size of the fan that you have on your unit, you could either screw it on or you could stick it on. Sometimes there are handles that can be removed, and you kind of print a spigot with a handle.
Oh.
Put it in, and
okay.
to your unit.
Now there is a unit there's a larger unit, right?
Yes.
And what is that typically used for?
So we say that that's the best unit for materials that you're unsure about what the emissions are that you're going to be dealing with.
Okay.
So we have a more complex carbon blend in the 3D Print Pro 4. It has 4 different carbons in there. And if you're working with resin printing, it's a really great carbon for you to use.
Oh,
or
really?
if you're experimenting with different materials and you're not really sure, you just want to capture the widest variety of potential VOCs that would be
interesting.
off-gas, that would be the perfect one for you.
I had the Print Pro 3.
Yeah.
And I used that articulated arm. I had a big Peopoly resin printer.
Yeah.
And I was printing a fairly obnoxious resin, the smell. And again, I was in an enclosed space. And so I used that articulated arm to put it kind of right there. And it really, really worked well at removing a lot of the smell that was associated with that specific resin. I hope it took away everything else, but I found that to be really useful, that articulating arm to be able to get in there.
So the carbon blend that we have in there, it's made out of coconut, and it's activated in a specific way that it's able to absorb a wide variety of the most common VOCs that are being given off. But we just made another solution just because in this industry, there's so many new things that are being developed every single day. You know, people are testing things at their home and people are making new things in their office. So we just wanted to create like a safe haul solution.
That makes sense.
Yeah.
You know, one of the things I want to ask, I know that the demonstration here is with a 3D printer in an enclosure, but there's been a huge advent in inexpensive laser cutters. And I know that those have to run a filtration because you're hitting wood or other materials, you know, with a really intense laser light and it off gases things. Is the BOFA solution good for those as well?
It is. It wouldn't be something as small as this when you're coming to laser cutting and laser welding, but we do have solutions for them.
Really?
Yeah. So BOFA as a company, we started off with laser coating, laser engraving. So if you take any of your food items, there's an expiration date that's either printed on or laser etched on. Every time that happens, there's a certain amount of particles or VOCs that are released. So it's become a mandated law for you to have an extraction system in place in your factories that are making these.
Really?
Yeah, so Coca-Cola bottles, everything, you have to have one of these. It's kind of become a tick box exercise because, you know, an unfortunate incident happened. So
well, that's usually the precedent, you know, that's usually the thing that happens, right? There's an unfortunate incident and then there's a law made, right?
Yeah. So for AM, we wanted to get ahead of the whole situation, provide a solution out there for anyone that's interested.
Now, as far as for everybody, one of the comments that I do hear a lot is because BOFA is a very well-built solution. And when we talk about people that are starting out with additive, you know, a $200 3D printer isn't uncommon. And so some people say getting a BOFA filter from my cheap 3D printer is like putting really expensive tires on my cheap car. And I get what they're trying to say, but you have to be able to think about filtration in a different way. It's not like just putting cheap tires. Like it's doing a lot more than just. I
completely understand their sentiment, and I think the solution that I would say is this doesn't need to be hooked up to just one unit. You could hook it up to multiple, to your post-processing station, because if you're washing your resin parts in IPA itself is a VOC.
Oh, yeah, it is.
Yeah. So you could hook it up to multiple, you know, things and reduce the cost that way. Or if you have a print farm at home, maybe you just need one of these, or maybe the 3D printer 4. And then you kind of save cost that way if you do some girl math.
But it is still difficult, though, to pitch to a more consumer audience because it is an expensive solution.
It is. It is made for the more industrial type of printers, but we want to look into providing a solution for.
Oh, you have a question?
Well, a comment. The audience is responding really positively to this and filtering and realizing that it's an important step that people need to start taking.
That's great.
Yeah.
Oh, okay. Just a comment.
I
hear from David of people really responding positive to this and how they realize that filtration is important. And that makes sense, though. You can't position your product to every aspect of additive. It's, you know, the $99 Micro Center deal for an Ender 3. It's really hard to position yourself a filtration system. It's like, well, you know, we can't compete with, or we can't exist within that price range, but it is a good filtration system, and it's available for people that once they get maybe a few more printers or run a farm or have a more professional installation. Is that about right?
Exactly. And until then, you know, vent to air, open up your windows. Don't be around the 3D printer when you're printing. Come back when it's done. But
so with the filtration system, I know a lot of people print with PLA, and typically it doesn't off-gas much. As far as materials go, one of the reasons why it's so ubiquitous is because it's really simple.
Yeah.
But since you work for BOFA, and you know, you guys are doing your experiments and doing your research, what is one of the materials that is the worst offender that people may not know about? Has there been any research or findings that is kind of surprising?
Well, a general rule of thumb is now that high temperature printing is very prominent around the market, as you go up in temperature, your emissions are going to increase. Same thing with laser powder bed fusion, you know.
Yeah.
As you have more lasers, you're going to have more emissions that are being given off. So that's a big thing to keep in mind. And that's why we need to create a solution that's out there for those higher temperature printers, because not only does it help with the atmosphere management and the safety and health of the people that are using it, it also helps with the cleanliness of the build chamber. When you're printing PEEK, you kind of get a sticky residue in a film that coats up the entire inside of the unit. So it kind of helps maintain that clean environment. Or even with resin printing. When you're also printing with certain fiber-filled materials, you know, you can get it clogged up, certain places. So it helps with all of that.
Okay. Well, I have to ask then, do you print at home?
I do not, but I really want to start. I do not yet, but, you know, I'm an engineer, you know.
You got plenty of printers at work to use, right?
I do. I do. And it's great. It's a lot of fun being able to print your own parts and seeing things come to life, 3D printing.
I like
honestly
it.
magical.
Well, I know we're kind of running close on time. I've got one more question for you.
Yeah.
One of the things that Formnext talks about now is sustainability and the ability and to inspire like kids in the younger generation. It's kind of like twofold. And so I want to lean on that other side of it and talk about how would someone who might be interested in filtration and atmosphere management find themselves getting a job at BOFA or in a company such as this? Like what aspects of learning should they focus on in order to find themselves within the industry that you're in?
Honestly, I have a background that's completely different to what I'm doing. But this, you know, I studied bioengineering, so it's kind of different to
That's still cool. That's still really cool.
Yeah, but as long as you're interested in learning, and for me, my goal was just, I wanted to do something that's going to make a difference, and this helps keep people safe. And that's the key thing that keeps me going at this job, you know. It's just providing solutions to create a safe environment for everybody.
Okay, so like kids and individuals who just like problem solving and finding really cool solutions.
Exactly.
That's one way to find themselves in this industry.
Yeah.
Thank you so very much. Thank you so much. This was
lovely
BOFA.
chatting with you.
And this was a lot of fun. And this is, you should filter your air. I'm sorry, you should manage your atmosphere.
Yes.
That is a fantastic terminology right there. Thank you very much.
Thank you.
I guess it's time we can take the smoke machine and the printer and get back to the booth. Okay, power disconnected. I'll let you guys take it. Oh, here. Well, thank you. Javier Mano, I use a super over-engineered soldering filter for my prints. It's amazing for soldering too. That's great to hear. I love hearing that because it's not just atmosphere management, it's also being able to creatively find a solution to a problem. And really, that's what additive manufacturing is, creative solutions to problems. Derek Geldings, like for a wood shop, you know, that's a really interesting one because people don't realize that within the atmosphere of a wood shop, you have tons and tons of really fine particulates, and you should filter those out. I know I have one. I know friends that have one. We get a ceiling mounted air filter, and I can just turn it on, or I can set it to just filter for like 4 hours. And anytime I'm doing any wood operations in the garage, I can turn that on and know that I'm getting some recirculation of air and I'm not breathing in a bunch of really fine wood particulates. I mean, I wear a mask too when I'm doing the dirty work, but it's just, it doesn't hurt, especially when it's in the garage, you know? The lights made it look like a mad scientist's invention. That's true. I don't think, the lights aren't included, right? The lights are not included? Okay, so what BOFA is saying is they encourage you to add your own lights. They encourage you to add your own lights. I think that's the way to do it. Ooh, live from New York 3D. I'd stick it near a vacuum former. That's a good idea. Oh, I think we're almost ready. Peter, let me hand you this iPad. That's right. For our next guest, he is dressed sharp. This is Foster from Stratasys.
What's up, Joel? How you doing, man?
What's up, man?
Yeah, I'm all
Good
right.
to meet
I'm
you.
all right.
So, funny story. I hear, because producer David had to be redirected on a few
That's right.
flights to get
Yep,
out here.
he did.
And serendipity brought you and him together.
Matchmaking, yeah.
What in the heck?
Denver, Colorado in the United States. We found each other and realized that we had a mutual affinity for baseball. Probably not the Cubs, but, but we did like, come on, that was a good, but we do like the Padres. I live in San Diego.
Okay. Oh, that's
so
fair.
yeah,
Okay.
yeah,
Okay.
yeah. So that's it. So yeah, it was really good to be able to reconnect with you guys. And this is a big event here for Stratasys. And
Oh,
we've
I
got
would
a lot going on.
imagine.
Yep.
Let's see. With Stratasys, we were able to film with automation.
You were, yeah.
Last year.
Yeah,
that was last year,
That's
right?
Yeah,
Okay,
yep.
that's right. So this year you don't have the automation set up, but you've got a really cool part here that you want to tell me about,
Well, I'm
right?
going to tell you about a couple of things. So I'll tell you
okay.
really quick. So at Stratasys, I'm responsible for aerospace. So I cover all the things that happen in aerospace. So that's commercial, that's defense, and that's space in general. So our
like space?
Space, like space. We're going to lunar. We're going to talk about the moon. We're going to talk about all things that have happened here in space. So there's a nice story to these parts. And
well, really quickly though, and talking about aerospace and additive, more and more parts are getting qualified for additive as time goes on, right? We're not seeing like the flyy parts yet, but
we are.
Are we?
We are.
Oh, okay.
For sure, yeah, for sure. And that's what we're going to talk about. But this has been happening for a while. But yeah, more and more of that is happening. More integration and adoption, and that's kind of squarely the focus for us. And so it's a challenge. I mean, the technology is ready, but it's kind of a people problem. It's not a technology problem. So we're ready to go with this. But
what is this part here?
Okay, so I'm going to talk to you a little bit about the history of kind of where Stratasys has been with like supporting big customers like Lockheed Martin, Northrop Grumman.
Oh, like big customers.
Big customers.
Yeah.
So when you're dealing with those customers, you got to have a really accurate and precise printer. And so this particular part we came up with about 5 years ago, and it kind of tells the story of our journey. And
let me borrow that for a sec.
Yeah, borrow that part.
There you go. I'm gonna let Peter take a look at that.
Does it feel nice?
It's really lightweight.
Yeah, it's nice, right? Got some nice lightweight, but it's also a nice stiff part, strong.
It's really sturdy.
Right. So this part is actually on the Orion spacecraft, right? And so we totally did. Yeah. So we built this part and with Lockheed Martin several years ago. But this is kind of the start of many things involving space and our journey with them. But now, if you were to take a look at Orion, there's several hundred parts that are on that
that are additive made.
Yeah, that are additive made. Stratasys additive made. So this material, right? It's called Antero, and it's an 840 with an ESD component. ESD is
super important for
space. Like we don't want static in space. We do not want an explosion in space. So this is really important, right? So
8040 meaning what?
840, yeah.
No, I'm 840.
840. I'm not exactly sure of what the designation
is. Is it like a nylon base?
Yeah, it is a PEC based material. Yeah, so it's a PEC based
okay.
material, right? And so we have it filled with carbon nanotubes, and so that's what gives us that ESD property, right?
That's really so cool.
Yeah, that's pretty rad. So we've got that going on, and so that's kind of the start.
Carbon nanotube filled PET based material in the PET based material in the Orion spacecraft.
Right. Yeah.
Stratasys
so that's out there, right there.
Oh, right you just like that's a tagline right there.
We love it. Yeah, I have a T-shirt.
I would
wear
imagine.
It to bed. So we do it every night. Yeah, it's great. So that is kind of maybe the start of this discussion. And so here we are now where we've advanced today. And so this is something that we were really excited to talk about. And this is a part for Northrop Grumman. You can see that right here. And we've collaborated with Northrop. And so the challenge that we're trying to solve is like when you go into space, radiation, right? There's a radiation thing that happens in space. So, what do you use to shield radiation? Well, lead, right?
Typically,
right? So lead is heavy.
Yeah, and so I've worn those aprons, like it's heavy.
And when you send things into space, you want them to be light because that fuel is very expensive when you're trying to send anything into space, right?
It has to be light because the less it weighs, the cheaper it is to get through Earth's atmosphere, right?
You're ready. Yeah.
Because heavy things can exist in space.
Right. Yeah.
But it's to get
past. There's a cost to the fuel, right? And so we're thinking about things like that. So why is additive a good solution for all this? Well, I mean, it helps you, part consolidation.
May I?
Right? Yeah, you may. Absolutely. got lightweighting, right? And,
Okay.
and then all the things that are, inherent in additive. You can iterate rapidly. You can find ways to, create designs and eliminate geometries. And so it's really well suited for space. So we really find a lot of value with our space customers.
Well, it makes sense.
Yep.
Well, when you talk about JPL in the early days, it was just a bunch of people who knew how to make stuff.
Yeah. Yeah.
And now it's the same, but now they've got really cool Stratasys tools.
Right. Yep. And so so the backdrop is, why do we need to have radiation shielding? And so that's what we're trying to, experiment with here. And so what this is a test box, and it's made out of the same Antero material that we used in this original, hatch cover here for Orion. But
PET-based carbon nanotubes.
PET-based carbon nanotube material, Antero, right, is what we call it. So it's a Stratasys material. And so what we're testing is we're going to test the effects of radiation on our materials in space. So we have 3 different technologies involved in this, right? So we're using what Stratasys invented, FDM, right, which is the extrusion technology.
Yeah.
And we have a couple of different resin technologies. One's a stereolithography, the other would be like a DLP technology, right?
Yeah.
And so anyway, we're sending these materials up on with collaboration with Northrop and NASA here in the summer, and we're going to be testing them on the lunar surface to understand the effects of radiation. What? And so that's important, right, Joel? That's
important, but that's freaking cool.
Yeah, that's really cool. So we're totally jazzed about this thing, but we think that this is going to be important because it's going to lead to a greater understanding of what can happen in space, which enables this technology in a radiation environment. What kind of effects do you have in a zero gravity environment? All of these things are really important. So we have this experiment's going to involve, there will be a lead, so what happens? Okay, lead covered little component here. I don't know if you guys can see this, but
here, let's
lead.
So, okay, Peter, right? You can see that,
so
right?
We'll have a lead there, and then
lead in each of these little spots.
Yeah, this is an example of what would be here, but this would be a lead, right?
Oh, I see.
So we would say, okay, so we're going to test the effects when it completely blocks radiation, right? And then we're going to have a tungsten filled, another Antero that we'll be testing here as well, to see how that responds from a radiation shielding. And then we're also going to have a ceramic based
ceramic for radiation shielding.
Yeah,
really?
Yeah, we'll see how that one works out. And so that's going to be our resin material. So that will be the testing the effects of that radiation on the lunar surface, all encapsulated in this box here, which is made of that Antero material. So it's pretty cool stuff.
That's really cool stuff.
Totally
now,
cool.
Wait a minute. So is the only way to properly test it sending it to the lunar surface, or is there anything you can do here on Earth?
Sure we can do that. We can do that here too. But I think that, if
you can't go to the moon, you do.
Yeah, what do we not know, right, when it's actually on the lunar surface? And so, this will ultimately, give us kind of a greater evaluation on the radiation as it goes. So this is going to be a really great kind So this will go up, and then we've got another aspect that we'll test a couple of other materials, another resin material, and another kind of FDM material too. So
it's really important to lightweight it too.
Yeah,
like you said, because the lighter weight it is, the more test boxes you can send up.
Right. Yeah. Can it allow us to print in space in the future? I mean, quite a long supply chain there. So we need to be able to shorten that supply chain, pass a file potentially digitally, with the right material. What do we need that to do in space? So we really think that that's not too far off. And if you talk to our friends at Northrop and of course at Lockheed, they say the same thing. So
if you can take lead out of the equation for needing to radiation shield stuff, you're taking away so much weight already.
And
just with that.
Yeah, what can you use that for in other areas?
Yeah.
And so it's change the game a little bit. So
this summer you're saying is when it's going to go up there?
This summer is when it's set, and so we'll be continuing to talk about that. But it's pretty exciting stuff. So that's one of the innovations that we're doing here, and so
that's pretty cool. Like you just kind of came on board here, and you're like, oh, by the way, so our materials are going to the moon,
right? Yeah. Like that.
Can you is it just going to land on the moon, or is it going to circle the moon?
There'll be a lunar lander, right? That'll be landing on the moon. So that's that rates a high five right
there. Dude,
that's rad. Yeah.
That's cool.
I know.
Like if you think about it, like additive is cool. We've printed things. I know people have printed things up into certain space, up into the atmosphere with weather balloons and whatnot.
Yeah.
Like people put stuff up on airplanes.
Yeah.
going 35,000 feet in the air, but the moon, the moon.
Yeah. So we don't think it's going to be, it's not a stretch to say that, we'll be able to print on the moon at some point. Well, how will we use that, as we continue to explore space, and how's this going to further our exploration and with these new technologies? So again, it's pretty exciting stuff. So
then at some point, at some Formnext, you and I are going to be talking.
We'll talk about it again.
About
We'll
this
say,
Stratasys
let's follow
machine,
this back up.
this new machine that prints using lunar regulus.
Circling back to episode 125, whatever this
That's
was.
right.
Yeah, I don't, you know, and then we'll come back to this very moment and say this is the results of this.
Wow.
So yeah.
Like I don't know your history. Like you're a nerd, right?
Yeah, I think I am a nerd.
You're
I
a
mean,
nerd.
I like talking to nerds. My wife says I'm a nerd. My kids definitely think I'm a nerd.
Okay,
So,
then you're a
so I'm
nerd. Yeah, you're 100% a nerd. Yeah, once your kids think you're a nerd, you're a nerd.
Yeah.
But like, just growing up, like, we're probably similar in age.
Probably.
Yeah,
you might be younger than me, but maybe.
Could be.
You look. Your
47?
skin looks good. 76, 1976.
Yeah,
I was
dude.
there.
Oh my.
Another high five.
Another high
We
five.
There's two of them.
But if you were like as a kid, that dream of space travel, being able to, you know, see the shuttles, see like that's ingrained in my soul.
Yeah, right. All of that. So yeah. So anyway, that was my history. To be honest with you, I was a Stratasys customer before I
No
came.
way.
Yeah, I was in the Marine Corps.
Okay.
I spent 20 years in the Marine Corps, and we were using the Stratasys technology to do maintenance and repair and all kinds of solutions. And so,
So can you talk a little bit about that? Like, what did you do for maintenance and repair?
So we would do everything on from repairing of ordnance pieces to ground equipment, to you know, tooling, fixturing,
Lots of tooling
all
and
of that.
fixtures.
That's
Yeah, of
easy
course.
stuff. That's like a no-brainer. But then we found a lot of value in kind of creating a solution, because these supply chains are they're ridiculous for DoD.
I would imagine.
It's a sad story, but anyway, you end up trying to find solutions, and we need to solve that too. And we're working with some of our DoD customers as well on how do we get better solutions, and how do we come up with policies that fit and work and allow us to do this. But anyway, so we were back to your question. We were using this to do repairs for pieces of ground equipment and aviation equipment. In my past life. So,
okay,
yeah,
but
awesome.
so you're out of the Marine Corps, then you're just like, hey, I know how to use these machines. I'm going to go knock on Stratasys' door and be like, hey guys, what's up?
Yep, that was it. And so we had a nice marriage, and here we are, 4 years later, and now I'm talking about space with you.
That's amazing.
Yeah,
like that's just
good.
a life of serendipity.
That's the way I live my life.
guess
Just
so.
serendipitously.
I guess.
Yep.
So then I have to ask, like being a nerd, you did your printing in the Marine Corps. You're talking about parts from Stratasys actually going to the friggin' moon. Do you do anything cool like this at home? Do you print at home?
I usually just bring it home. I mean, there's my house smells like polyjet materials, and a lot of little Yodas positioned in the house. Sometimes you get on Halloween you get a pumpkin every once in a while.
Yeah.
So we'll bring that home.
Okay.
Part of the display for the kids.
Sure.
But that's what we do.
Oh man,
That's awesome.
Is there any way that people at home can participate in how wonderful this is? Like I know Stratasys on the industrial side, like ceramics and this pet-based material.
There's no way they could do that at home.
No, they can't do it at home. But like, how can they? Are there cool papers on this?
There
so if they go to stratasys.com, they can read about this.
You can absolutely read about it. We'll be putting out more specific information on this, down the road when we execute. But yeah, we've got a host of white papers and volumes and volumes of work here that we could talk about for some of this stuff. So Stratasys is we just do our long history. We've had a lot of benefit of working with some of these great customers, and every time you talk to them, they're like, man, this guy, this person, they're pushing the limit, and they're really extending the horizon on what this technology can do. So we listen to our key customers, and they give us the answers to the test, and then we'll go create the solutions.
Then you create the solutions there.
It's a good setup. So yeah.
How often are solutions found internally versus within key customers?
Key customers drive it. Yeah, we're squarely focused on the key customer, and there's.
Well, did NASA come to you and being like, we need better? Really?
Northrop and NASA. Northrop initiated this discussion, but we NASA-driven requirements through Northrop to Stratasys, and we again, this is one of our Northrop Lockheed, one of our key customers. We do quite a bit of work with them, but we have very close relationships with a lot of their very sharp tech fellows and engineers, and they're informing us of the problem, and let's come up with a solution to solve this together. So yeah,
that's a really interesting way to go about things, though. Have most of what you do being customer-driven solutions. Like it ensures that the research that you do isn't for something that may not be wanted. Like everything you're doing is working towards something a customer wants or has expressed interest in.
Well, we think those organizations like a Lockheed, a Boeing, an Airbus, Northrop Grumman, these are the pacing organizations, the Blue Origin. They're determining, where we're going to take our technology development.
Yeah.
Where are we going to create our next, DoD platform? how are we, innovating for commercial aircraft to, find lightweight solutions or whatever that the problem is. And so it's a great match, and we've been grateful for those relationships.
Oh, I would imagine so. Well, let's. I know we don't have a lot of time left, but I really want to talk a little bit about aerospace, because the additive parts qualified for aerospace have grown.
Yeah.
And how?
You're going to ask me a number, aren't you? Are you going to put
No,
me on
no,
record
no, absolutely
for this?
not.
Okay.
I want
Okay.
no number,
Okay.
but I'm just, in the coming 5 years, what do you envision additive's role in the aerospace industry in 5 years? Like, how much do you think there's a key qualification or a key component that needs to be approved before we get a hockey stick in a graph somewhere?
Good question. I like the way you frame that too. So I think that what we've experienced right now, just in additive in general, let's just talk about we've had a lot of the early adopters, like the people that are nerds like us.
Oh yeah, nerds like us.
Take this on and think that we can do something here. And a lot of those early adopters have already started to accept it, created their own specifications and qualifications for parts that are flying, wherever they're flying. And then, now we're at the point where we're kind of at this inflection point where we really need to go from the early adopters to the early majority.
Okay.
We need to cross that chasm collectively as a group. And it's
more difficult than you think, isn't it?
It's very difficult. And as I mentioned, it's not a technology issue, it's a people issue. And then we need to solve that together and say, what policies do we need to have in our government that will allow for more of this, that will allow for a digital supply chain, that will allow for the integration for manufacturing that we can take into these other areas. And so we're really committed to that, and tying in that government, that OEM, prime vendor, and then ourselves, trying to solve these problems. And so it requires continued development of technologies that will enable confidence for the engineers to be able to adopt this, whether that's giving them readings, and feedback on mechanical properties as it's being produced, to get away from all this testing that we have to do on the back end of the print. So we need to overcome that hurdle. We don't want to be in the business of testing all the time afterward. We want to be in the business of, getting that information while we're printing.
That makes a lot of sense, actually. Well, and I know we're short on time. One more question.
Sure.
You talked, because we talked about the government and policies, and the DoD side of things. For people to be able to participate who are interested in the additive side of things, are there specific things that they could call and ask their representatives, or perhaps like certain positions within the government that they could question as to say, I'm interested in this going forward?
I think so. I think we have to, because just really quick, the global environment, how important is it for us to focus on things and shortening the supply chain, both from a sustainability standpoint, from a nearshoring standpoint, for our national security. These are all important things. And so, that's absolutely something that I think that people can do that are, in the industry or have interest in this. The technology, again, is ready to go. And how do we kind of get past some of these policy inhibitors that might be in place to make a digital supply chain?
The people issue, if the representatives hear from enough people, then that
100%.
becomes less of an issue,
Right.
hopefully.
So how does our government drive additive innovation into DoD programs, for instance, or NASA programs, where we're doing a certain portion of a lunar landing craft that maybe has additively manufactured parts, right? So is there an incentive for that? So that's the kind of stuff I think is important. It's a great question. Appreciate
That's
that.
cool, man.
Awesome.
Well, listen, Foster, this has been amazing. I'm
great,
really
great
thankful
time with you.
David found you on that airplane, and I'm going to come by the Stratasys.
Well, you're welcome to come to San Diego anytime. We'll go to a Padres game, and maybe we'll
don't threaten me with a good time, Foster.
All right,
hey
Joel,
man, have a good rest of Formnext, man.
For sure. Okay,
I'll let you take your parts.
All right. Well, by the way, I'm going to plug the F3300 that is also being launched today as well.
F3300.
You need to check that out. It's our next generation technology, built from the ground up, a completely new approach to FDM. 30 new patents on this technology.
Jeez.
Yeah, it's pretty impressive.
You did some good stuff there. Okay. Well, I'm gonna go by the Stratasys booth at some point.
Check it out. We got free beer too. All right.
And there's free drinks. I like it. See you, Foster. Take care, man.
Oh, fantastic.
Awesome.
Great work.
Well, that wraps up the show here at Formnext 2023. What an incredible lineup of people, punctuated by 3D printed parts from Stratasys on the lunar surface. I don't know if I've ever said anything in my life that's as cool as saying 3D printed parts on the lunar surface, but the only thing cooler would be if I could don a spacesuit and go to the moon with them. I think that'd be a lot of fun. I'm I'm a little tired from standing for 3 hours and talking to some amazing people and showcasing amazing things. I really hope you enjoyed your time here on the stream. A big thanks to Peter for running the camera over there. Thank you, David, for helping wrangle all the guests.
Hey, you're welcome.
And I don't know, at this point, I just want to say I love you all. Thanks for watching. And if you made it this far, you're awesome. Don't forget to hug each other more. Fight for a cause you believe in. Print all the things. How appropriate here, right? And as always, high five.